Hello, good morning all, and welcome to participants from various states and UTs and Team NJJM who have joined offline here in person as well as online. Uh, Friends, you know, we have heard of various institutions like which builds missiles, builds satellites, okay? Uh, but this is first time I am seeing that there is an institution called National Institute of Water and Sanitation. It's first of its kind. So first of all, I would like to congratulate the team NJJM and for the spirited efforts, untiring efforts put in by Pradeep Singh ji and NJJM and the whole team. So I would like to give you a big round of applause, please. Uh, and first time I am also seeing that it is a paradigm shift that the benchmarking parameters for water service delivery is being monitored and measured. Okay, and you know, JJM and JJM, they have very comprehensive vision. And I can see that they have taken on board all the stakeholders, be it academicians, researchers, industries, and end users. So first time such a model I am seeing that all the people are on board. And there is a role for CSIR, okay? So what role we are playing? Because in this presentation, what we will be going through, many of you will be coming across first time. And so we would like to just take you through the some kind of, introduction and what we are doing, what CSR is all about, where we are engaged with. Okay. So first of all, we are engaged in developing the technologies. Okay. And technologies of different kinds, the technologies which are not available in the country, in all the IoT architecture, with the sensor systems, IoT, cloud, and data analytics. And secondly, upscaling the technologies which are available in the country, but they are not compatible with the IoT system that we are talking about. So upgrading them, augmenting them, and bringing it to the level that there's network, we can integrate them to the network, IoT networking. So this kind of technology role that we are playing. And we yesterday we talked about lot, and many speakers talked about the standards and formats, and we seen that they express some difficulties in compatibility of the formats. So and there was some discussion also happening, and somebody inquired because different states are going with their own approaches, and there is going to be issue with as far as the compatibility of the standards and protocols is concerned. So one of the important responsibility that CSI will be playing is standardizing all the documentations, formats for sensor calibrations, IoT hardware and software, so that upscaling across the India, pan India happens and it is uniform. One country, one protocol. It's not that in one state something happens and then it is not applicable to other states. So plug and play modules, we just like any pen drive you are using in the computer, be it of any make, you just plug and it plays. So that kind of one country, one protocol. So CSR will be working on the various standardizations of the IoT software, hardware, and calibration standards, so that it acts like a kind of reference handbook. CSR will be coming out in all these respects, which can be followed for referring to the standards in various IoT architecture. And thirdly, we would like to build a complete IoT ecosystem meeting national requirements, okay, so in terms of scaling up and supporting the industrial collaborators, MSMEs, and startups. So creating an ecosystem. So not only installation of the IoT, because this has to be sustainable. So for sustainability, we have to create a complete IoT ecosystem footprint across the country. So these are the kind of roles that CSI would like to play. So I'll be taking you through, these are some basic details, who are engaged and all that. This project was, deliberated for 1.5 years and so, and principal scientific advisor, he was a task chairman. We went through all this process, and this complete consortium has been built based upon the complementary expertise available with the different labs. These are the objectives that this project will be delivering, wherein we are actually going to customize the various online, offline sensors, indigenous sensors, off-the-shelf sensors, so that they are network friendly and they can be monitoring the quality, quantity, and regularity. Then we'll be calibrating them, standardizing them, integrating them, and demonstrating in the pain point affected areas, and making this, information available across the stakeholders, be it gram panchayat level or state level, district level, state levels, and central level, so that various operation and maintenance aspects can be mitigations can be carried out, and sensitization, troubleshooting, remedial interventions can be carried out. So these are the kind of objectives that we will be delivering in this program. And at the end, we are going to come out with a smart systems, smart water resource management system, complete digital transformation of the water resources, especially water service delivery in the rural sectors. These are not just the IoT monitoring system. These are going to be smart systems. There is going to be sense making in the sensors, in the gateways, in the cloud, and in the dashboards. So that kind of system we are talking about. And these are the key features wherein, this kind of problem statement came to us, wherein we have to actually work on various aspects, like be it cost effectiveness, be it innovation in various sensors, and be it, there are problems such as grid power is not available, and defining the standards of hardware, software calibrations, and methodology and processes. So all these aspects which are actually required for the IoT base monitoring of the water service delivery will be carried out, and a different dedicated labs have been roped in from the CSR who have the requisite expertise in that particular domain. And what we'll be delivering, that at the end, that it will be monitoring the service delivery, water quality, quantity, and scheme functionality, just status on the go, as we all know, and the kind of dashboards, as you can see, will be made available. And it will be also possible to make available the forecasted demands of the water requirements, current source levels in the source, and recharge patterns and usage patterns, and thereby it will be helping in terms of the operation and maintenance and effective utilization and water service delivery. And this will all enable this, the stakeholders to take the remedial and mitigation actions timely. This sensor, Shotik, do we have pointer? This program is talking about a lot of innovations, actually, because we cannot buy something which is available abroad, imported one, and fit into our requirements. That is not possible, because they will never give you the access to the internal cores, software, hardware, and all those firmwares, etc., so that you can completely customize site-specific requirements and cyber security related issues, safety issues, so that it is not hacked and all that. So all these is possible only if you have completely indigenous solution in terms of the sensor system, IoT, cloud, and data analytics, complete value chain system. And this will have important aspect, that interoperability of the different layers. And for that, we are going to develop a kind of extraction, transform, and loading layer inside each device, so that there is a interoperability. And it is works on a kind of open source platforms, and there is no particular vendor which is having a monopoly on this, that only his system will fit into this thing. So we are going to have that kind of extraction, transform, and loading layer, so to enable the interoperability and standardization of the various protocols at the device layer, using these low weight machine protocols, and at the gateways and at the cloud level, which will follow different, like socket security layers and all these protocols. And calibration, different types of calibration, periodic calibration, preventive and predictive maintenance related calibrations. And we will also have indigenous risk pioneer software and indigenous cloud Sagita, developed by the CSIR, for variety of applications required by the stakeholders, be it a pipe condition assessment, contamination risk assessment, replacement planning of the water distribution network with cost estimations. And those who are into this, they know what is the importance of these aspects. And vulnerability assessment, that how vulnerable your network is for the failures and all that. And we will also compute the water quality index, which is a single aggregated unitless number, which tells you and informs you about the water quality in a particular site. We will have different alert mechanisms, okay, and we will be building a lot of advanced analytics into this, comprising of the leakage and unauthorized connection detections, water level in the source, pump operations, pump health, water treatment plant operations, water quality, quantity and duration of water supplied. Besides this, we have advanced analytics such as forecasting of the projected life of water source, predictive maintenance alerts, because your sensors, you might be thinking that sensor is giving good data, but it may be erroneous data. So there will be a predictive maintenance of various components which are in the distributed systems, and non-revenue water loss that will be also forecasted, and demand estimations. We provided something like this. What we will be doing, as we all know, there will be sensors for monitoring the various key performance indicators, okay, across the line, starting from source to the delivery point, okay. And that we all discussed yesterday. It was a very good exercise wherein we estimated the bill of materials. So we all know where to fit what sensors. And this demand specifically comes from the states, because they are actually the owner and they know where to fit what. And there are four key technology research vectors in this, which has to be mastered and which has to be indigenized, which comprises of the sensor system, IoT, different transceiver modules for the short range communication, long range communications, and cloud and data analytics modules, and application layer, of course, the dashboard layer and all that for the various possibilities like mobile, desktop, and tablets, etc. So this is a novel smart IoT architecture. We call it IoT-A for water quality monitoring that CSI team has proposed in this program, in which you can see that there is a water distribution. There is a layer at the bottom. You can see that there is a water distribution, quality, quantity monitoring and treatment, which is called as a physical layer. After that, there is a device layer wherein we have different sensors, actuators, flow meter, pressure gauge, GLS, pH, and all water quality sensors. And after that, there is a local communication interface. We call it RTUs, okay, or nodes. And from that local communication interface, it goes to the remote communication interface. And there are various possibilities comprising of the GSM, LoRa, and Wi-Fi, etc., depending upon the availability at a particular site. We can have first mile connectivity with the LoRa. So those combinations can be actually checked depending upon the site's requirement. And then we have the service layer, okay, wherein then this gets uploaded to the cloud at different databases, data centers. It can be public and private clouds. And we know that already CSR also has its own data servers. As I already told, the cloud, Sagita, indigenous cloud. Then already Tata is also working in this direction with the NJJM. They have also built some these cloud platforms. And finally, there is an application layer wherein the dashboard data analytics will happen through the RESTful APIs. We are transferring it, migrating it to the application layer, and there will be visualization of the analytics, KPIs, machine learning algorithms, and it will be finally displayed on the user and mobile desktop applications, developers, data factors, alerting mechanisms. So there are different application layers and different privileges are given. So this is how we will be doing. So physical environment is there. We'll be, putting the devices, having the different format, JSON format. They have to be device ID, device type, timestamping, and parameters. And then finally communicating through the cloud and to the application layer to the consumers. And this is the particular architecture that CSI proposed, which is called a star up star topology, wherein in different villages, we have optimized the energy efficiency. Okay, because battery is playing a very, very important role here. So depending upon the what kind of ranges are there, what kind of kilometers, if it is within 100 meters, we can go for wired, Wi-Fi, Bluetooth, or it can be wired also. Okay, 420 milliampere protocol or the Modbus protocols, okay, digital format. So that depends upon the complete requirement at that particular site. And then we have, as you can see, there are different clusters, and in each cluster there are local RTUs comprising of the local displays also. As sir was telling yesterday, that if there is no power or the network is down, on the local display, it will be possible to see the data. And this local display in each clusters, they will be able to store the data for 30 days. And these are bi-directional, meaning that from the master gateway, from the cloud, I'll be able to change the, over the air some security patches or some calibration things. And all these can be fixed from the over the air bi-directional communication. So these are the requirements as per the Ministry of Jal Shakti Technical Committee report also. And we have complied with that, and our technology, what we are developing indigenously, are actually in line with all that requirement. And the master gateway will be able to store the data for 6 months. So this is how the whole structure has been built. And We will also follow the various formats like the service reservoir, water level. It will have specific format. This is what we are calling as formats which are to be uniform across the country for interoperability, and it will have all these particular formats, JSON format strings to be communicated from the device layer to the gateway layer and to the cloud layer. So same way we will have these formats for the pressure sensors or any other sensors and devices that we'll be employing. In each device, for example, this is a for flow meter wherein we have device ID, flow meter 1, 2, 3, and device type. Okay, that is flow meter and parameter T, F, B, E. T means quantity in liter, F means flow rate in liters per minute, and B is the battery life and errors related with that. So this is how the different formats will be used. And from this master gateway, master data aggregator, data loggers, that will go to the state, because as we know that state, yesterday somebody was saying that the data should be available to the state as well. So from the local, right from the Gram Panchayat level, the data will be pushed to the state clouds by these master aggregators, gateways, and then from the state clouds, the data will be pushed to the center cloud through the APIs. All the relevant framework has been already designed by the different CSR labs who are working in different work packages. So how we have distributed, because it is a mammoth task and it is a very a comprehensive exercise, we have completely divided the things into various work packages, which comprises of sensor system, IoT, cloud and data analytics, dashboard visualization, and power systems. Because power system is something which will make this all network long lived and perpetual, and they have to be also cost effective, and the battery life should be, they should be able to operate on the solar, renewable and non-renewable energy sources as well. So you can see different work packages are handled by different, there are different tasks under work packages, and different leads from the different labs are working on that. And this implementation of work packages is actually addressing the various problem statements mentioned by the Ministry of Jal Shakti. And this is the present current progress, because we will be talking about the innovations in the sensor, what CSR is doing, IoT sensors and different cloud and data analytics and dashboard technology. So present current progress in this direction is that we have already completed the phase 1 lab scale testing of the off-the-shelf sensor completed, and proof of the concepts of the indigenized IoT sensor has been completed, that is phase 2, and development and testing of the offline and online prototypes is in progress now. As you can see in the right hand side, this is one of the IoT field test bed for the Jal Jeevan mission, which has been created in the CSI Chandigarh, which has been recently visited and reviewed by the local task force committee. And we shortly would like to get it inaugurated by Pradeep sir or something like that. So this is already getting ready, and our team is quite hopeful and working with a full enthusiasm that by January end we should be able to make it operational. And besides that, we have already submitted, because the next step, if I go to the time scale and work plan, we have to go for the upscaling in the different states and create a kind of benchmarking sites, because the model is that we are developing the various technologies and then we are putting these various technologies into various states as a benchmarking sites. We are calling it as a pilots, so that these benchmarking sites will be acting like a kind of reference for the states. For example, we established 20, 30, 50 or 100 pilot sites, benchmarking sites in each state. So all the learning and guidance in terms of the technical compliances, techno-commercial compliances rather, I would say, will be used by the various state representative when they will go for the upscaling, okay, with the industry collaborators. And in fact, while we put in all these benchmarking sites, we will be also taking on board the industrial collaborators. So industrial collaborators will be given the hand holding right from the beginning. Okay, so they'll be learning the all nitty gritty of how implementation happens. So the training happens. So everything is going concurrently. And this is how the model is going to roll out. So each state need to have some at least 25 to 50 or 100 benchmarking sites, so that they act as a reference guide to further upscaling, because we have lakhs of villages, and all the compliance should be there. So that is the actually vision and the model that we would like to follow. In that direction, we have already submitted the DPRs to almost 13 states, and we are awaiting the responses. Some of the states are already moving forward, and they are at an advanced level. For example, West Bengal, Haryana, Manipur, Goa, and Ladakh, they have already on the verge of, and some of them already cleared the SLSSC approvals. So the next step will be actually implementation. So this is the present status, and we have already activated the CSI Science Center site, wherein this site, this has been already deployed, and CSI field tested is already nearing completion. And this is the status right now for the DPR submission and all that. At a glance, I have given that status proposal and status proposal submit SLSSG approval, etc. And this is the timeline. Phase 1 we have completed, the upscaling is awaited, and phase 2 integration is in progress. And now I'd like to take you through the various innovations that we are carrying out in the various sensor systems that we are developing. We are already developed a ground level, water level sensors up to 30 meter. It has been fabricated and tested successfully. And we are now taking the trials for the 70 meter indigenous ground level sensors. And similarly, we have optical water level switch, which has been fully tested and is ready for the deployment across the country. And then we have another technology on PS, turbidity, salinity, TDS sensor, which has been designed, a miniaturized rugged mechanical enclosure is there, protection mechanism for the sensors. And we also have developed a signal conditioning circuit, very refined and which gives a good signals for this technology, and with the security enabled certificates, because we cannot just connect any sensor without any security enabled certifications. This is the pH sensor. There are different innovations in terms of fabrications, because they have to be rugged and field operable. Okay, and they are going through rain and temperature and dust and all that. So they have to be rugged. So accordingly, an installation maintenance guidance is also actually taken into account, and I have given the details over here. And similarly, we have worked, and these are the test results of all the various sensors that we have developed, which comprises of turbidity sensor, electrical conductivity sensors, and there's a lab, NIRI lab, which is dedicatedly working on the calibration and testing of the various sensors. Because any sensor, you might have seen that on GEM or purchasing, everybody says that we are giving PS sensor, but they vary a lot in terms of the specification and the performance. So therefore, this needs to be taken into account very carefully. And same way, we have TDS, salinity, conductivity sensors that we have done, and they are tested. And then we have developed the indigenous residual chlorine sensor, wherein we are employing the amperometric principle, in which it is a kind of type of potentiometric technique, wherein we are measuring the current with respect to the time and keeping the potential constant. So that kind of technology for the online or offline field usable measurements we are doing, and you can see the results are quite encouraging. The R square value is 0.98 and the RMS is 0.03. The error is 0.03. And you can see that 0.1 was predicted at 0.13 and 0.4 was predicted at 0.34 and 1 was predicted 1.01, this ppm values. Okay, so this is the latest design. Now this is the lab scale we have done, and field scale we are now moving forward.
Let's
And
now concentrate on the amperometric measuring
this is
principle.
how it works.
An amperometric sensor usually consists of a gold cathode, also called a working electrode, and a silver chloride electrode that forms the anode. A DC voltage is applied to both electrodes. Cathode and anode are located in a reaction chamber that is filled with an electrolyte. A membrane separates the reaction chamber from the medium to be measured. The membrane is made of a superhydrophobic PVDF. It allows gaseous HOCl molecules to diffuse, while it repels OCl ions due to their negative charge. The membrane shows a behavior similar to cell membranes of bacteria, for example. When the sensor is immersed in a medium containing free chlorine, the HOCl molecules diffuse through the sensor membrane and are reduced to chloride ions, Cl-, at the gold cathode in the reaction chamber. At the anode, silver reacts to silver chloride, releasing electrons. This results in a current flowing through the discharge system that is connected to the anode and cathode. This current is proportional to the concentration of free chlorine. The current is processed in the
Yeah, so that was all about the chlorine sensor. This is the latest model that we have already designed and fabricated as well, and it is under now testing. This is about the next innovation in the sensors, nitrate sensor, indigenous optical principle based, which uses the Beers-Lambert's law. The absorbance is proportional to the concentration and the path length and absorptivity. So this is how we have found the result, that the R square is very encouraging, 0.99 coefficient of correlation, and the RMS is 0.4, and this works within the accuracy of plus minus 1 ppm. The allowable permissible limit is 45 ppm in case of nitrate, and the various states such as Maharashtra are affected with this kind of contaminants. So this sensor will be able to cater up to a range from 1 to 100 ppm, and we have already developed several versions of this, as you can see at the right hand side. They have already deployed at the CSI test field build. These are the various versions, innovations, and installation maintenance things. Similarly, we have another innovation in the fluoride sensor, indigenous fluoride sensor, wherein we have this, phase one, we have used the off-the-shelf sensor, and in phase two, indigenous sensor we are developing, wherein we have already found encouraging results of R square 0.92 and root mean square error of zero point 0.4. And this also will be able to give us a result from 1 ppm to 50 ppm, and 1 to 1.5 ppm is the allowable acceptable limit, and so we'll be very much able to cater to that range.
This is a schematic view of how the instrument looks inside. Of course, you need a light source at the entrance. You need a vial or something where you can put your fluorescent sample. And then you need typically some kind of optical filtering at the excitation side. So you select which wavelength are you going to excite your molecule with. This is illustrated by a green light here, for instance. On the fluorescent sample, on the fluorescent light, you also typically insert a filter so that you pick out the peak of the emission, and then you measure that by a photodetector. Often you would like to have a 90-degree geometry as shown here, because then you have a good separation between your direct light, which you don't want to be interfering with your detector, and the fluorescent light. So they're kind of separated. So
yeah, so this is the principal transduction scheme that we are using in case of the fluoride, arsenic, and iron detection. So these are the innovations that we are doing in this. These are the various molecules and compounds that our team has developed in various labs for detecting all these arsenic and important sensors. We are in the process of, we have developed the offline prototypes, and we are developing the flow injection-based system design for the field-based systems. And this is the flow meter things that we have done. We have already installed, and these flow meters are under evaluation at the various sites, and we have also conducted the visit at various sites. And calibration methodology, we have tested the various sensors, off-the-shelf sensors, and performance evaluations have been carried out for the various off-the-shelf available sensors as well as our indigenous sensors. And this is the calibration methodology that we are talking about. The user will be able to, calibrate the sensors at the site, also from the remote end by these possibilities, and provide the curve fitting, corrections by using 3-point or 5-point calibrations. And we are using our lab scale, reference method. These are actually carried out with the reference method using the various instruments. Now, once we have the sensor, as we know that generates the electrical signal, and that then we need to have, they are converted in through the algorithms into some sense making and particular attribute of interest like fluoride, nitrate, or arsenic or pitch, and then we have to transmit this information to the to the cloud. So for that, CSR again developed the indigenous technology of LoRa, which works on two ways. Like there is a LoRa and there is a Wi-Fi based technology that we have developed, and this can be deployed for the various sensors. And we have went for the chipset based approach, wherein initially we tested with the LoRa modules, and then now it is the chipset based approach, wherein we have the microcontroller, LoRa radio, peripherals, all combined in a single PCB. And you can see the development cycle, wherein the proof of concept has been proven, engineering validation test has been carried out, design validation test has been done, because I have shown you the CSIO test bed and different variety of the versions of the, these are all our own developed, designed within the labs. And we have also carried out the testing at a line of sight and without line of sight scenarios. And presently, we are able to operate it up to 2 kilometers. We are taking the range for up to 5 kilometers shortly. And this is the work on the cloud. We, as I told you, CSR has its own Sagita cloud developed, and data cloud architecture and all these things have been done. Node cloud security and cloud dashboard security protocols have been established. An IoT data exchange format has been frozen for all the communication between node to the IoT gateway and to the cloud. And secure REST APIs are being now developed, and initial testing with CSR Science Center for various sensor has been initiated already. And this is the dashboard. Probably if the time permits, my team is already awaiting online to give you the dashboard demonstration online live right now. And in this, we have already done the monitoring locations of sensor details, live data display for the various parameters, quality parameters, and we can switch. There are various features which have been added by our team, and now ongoing schedule of database backup from primary server to secondary server is ongoing, and we will keep the track of secondary database size and backup databases before exceeding the storage limit. Similarly, important component technology component is power systems. We have already developed the indigenous power system wherein the grid as well as the solar panels can work. And these are the test results for this power system that one of our lab is dedicatedly working. So our own indigenous modules for the power systems. And you know, all this indigenization will drastically make the impact on the cost effective utilization, because we are talking about 5 lakh scale of the villages. So only vision of JJM will be possible if we have indigenous technologies available. Otherwise, you know, 1 lakh or 2 lakhs costing residual chlorine sensor will not think of, you know, deploying it across the country. And these are the all test results for the power system that we have developed. Now, finally, this is the last work package and last work progress. I would like to inform you that in the phase 1, we have already done the field scale test bed ready. Pilot approvals are awaited from the states and UTs for the upscaling. DPRs already submitted to 13 states. SSC templates are also awaited from this. And for phase 2, January 2023, as I told, a field scale pilot will be ready, and a dashboard will display all these descriptive key performance indicators, and indigenous sensors will also be deployed by April 2023. And this is the indigenous components. As you can see, almost in phase 1, 20, you can see by the end of the phase 2, we target to take it to the 90% indigenization of the components for the various tasks, 14 tasks and this thing. And Pradeep sir knows that we provided the cost estimates also. It will have huge impact, because one village, if we say that 2 lakhs rupees, then 5 lakhs villages, it will be 20,000 crore rupees, and then the impact is going to come out to be around 2 to 3,000 crore rupees if we go for the indigenous components. So these are the roles and goals which I already talked about, that the R&D for the localization of the technology components, standardization of the protocols, documentation to act as a guiding light for the third-party audits or regulations for the IoT pilot implementation in terms of the techno-commercial compliance of your IoT ecosystems, develop technology components which are not available in the country, and localization for the upscaling and augmentation of the in-house component, that means off-the-shelf components. So this will create a complete IoT ecosystems in the country and self-reliance in terms of this technology. So one country, one code protocol I have already explained. This is the progress which I have already given to you, and these are the brief details in term with respect to all the tasks that we are carrying out in this. And interaction with the states, we have already moved in the steps that was prescribed by the ministry, that we have to create DPR, we have to interact with the stakeholders, we have to create the SOPs for the industrial collaborators. So these are some of the pictures while we visited the various sites, and it is still in progress. So this is the benefits to the states while they work with the CSR and NJJM. NJJM and CSR, they have, kind of working as a partners together, and with the states, a model is created. There will be technical and commercial compliance, no irregularity in terms of all that. Uniformation and standardization for pan-India upscaling, indigenized product that will help to give a repair, replacement, and less breakdown time. Otherwise, if any sensor goes down, it takes 1 to 2 months to get the new sensor, because that is coming from abroad. So local ecosystem for long-term support, because there will be local skilling who will be able to repair the sensors also locally. This is the progress in terms of all these phases and phase 2. This is the next work plan. Support required from the states, that we have actually created a site specific details, because what is required in your state we don't know. We visited, okay, we will visit, but then we need to have information ki kaun se line size ka flow meter lagna hai. That line size I am not aware. How many pressure sensors you want, what kind of water supply schemes do you have in your states. So local site specific, those parameters need to be coming from the states. Only then we can form a complete design for you. Thank you so much. I have team. They may, Dr. Ashish, if you are there, you may share the live dashboard demonstration.
Yes, sir. Yes, sir. Thank you, Dr.
Jyoti, can you
Bhavan.
help? Yeah.
Now we can go ahead for the live demonstration. Shubham, could you please share the screen? Dr. Bhavan, please stop sharing your screen so that we can share that our screen. Thank you. This is the dashboard which we have developed. Our team has developed. Start away, you can see that it is we have created a specific domain for the dashboard, that is harghar.nal.niri.in, and it is running on HTTPS. So first we have take all the security measurement, that all the communication, all the data which is flowing through from cloud to the dashboard should be secure and encrypted one. So the unauthorized access may be restricted. So therefore we have put the SSL certifications, and these are the sites you can see. Currently we are getting live data from 3 of the sites. Shubham, you can zoom in to that any one of the site. Yes, this is our science center. This is our science center where we have different sensors. Anybody can tick on the what these are the parameters. What are the parameter you are getting? You just click on the that any location, and on the right hand side you can see that the device code, all the data is as per the JGM norms. What they have provided, that device code should be like that: gateway, device ID, village ID, and then finally the parameter which is captured, and the device, all these as per the norms. When the device is maintained, who is maintaining the device, when it is installed, all the data is metadata. Basically, the metadata about the device is given there. And then in the lower bottom, you can see that the time series data, you can see about the device, what are the data is we are getting. And the same data is also reflected on the table. In 15 days or 20 days, we will also put the analytics. Now we are getting data from at least 3-4 months. So now it is sufficient data on which we can have an analysis of the data also. We will provide the maximum, minimum, what are the outlier, when, how many times the device is down. All type of this analysis will be available on the dashboard. And secondly, this is the live data. The dashboard also catering with the secondary data which we are getting from different states. Shubham, can you zoom into that Goa state from where we have also a secondary data? So we are also gathering, like our friend Dr. Bhavan already told, that we are collecting lot of secondary data as well, that population, total demand in the what is the demand to consume, supply to demand ratio, what is the how much LPCD we are supplying. You can tick on any of the button, like LPCD or device district wise view, what is the NRW status. So here from you can straight away you can know that which are the districts which are getting good supply, where are the district or taluka where we need improvement. These type of data is we are collecting. And as far as the storage of the data is, we are making the provision to store at least 6 months data as of now, and which can be extended as per the requirement. Which can extend, we can go up to 1 year also. So this is all about the dashboard, and you can also change. There are various layers are available. You can switch between different presently. Shubham, can you zoom out and show the different layers we have, like background layers? Like for example, if you want to see that presently there is the open street layer, but if you want to see the terrain layer or satellite images, like you can also see that satellite images also. So you can pinpoint the location where we are. You can zoom into that any one of the sensors. Zoom, go to the any one of the sensor and zoom it, so we can see the location, exact location where the sensor is installed. We can pinpoint straight away. This is the Lodhigana, which is our science center where we have put the sensor. So actual location of the sensor we can see where the. So this is all about the dashboard. Any query we will like to solve. Thank you, Dr. Pawan. Dr. Bhavan, thank you. Shubham, you can stop sharing now.
Thank you, Dr. Ashish,
Yes.
for explaining the details. And as you have said already, a lot of data analytics things will start happening, and different layers in terms of security and all those aspects they have already worked out. And end-to-end data transfer, starting from device to the up till the dashboard layer, has been completed. And let me also inform, this is available, sir, in desktop as well as the mobile app. You can just will share. You
Right.
can download anytime. It will be available.
Yes, yes.
Now, also I would like to see, you might have noticed that the values are not actually showing correct. You might have noticed. Uh, yeah, yeah. So, sir, we are already aware of it. What is happening that all this is going under testing now. We found that the kind of flow cells and those systems that we designed, the sensor went wrong, and some of the corrosion happened in the connectors and all that. So this is also a kind of thing. While we evolve a technology, there is a complete cycle, sir. So while we evolve a technology, it undergoes through a lot of things. So we are now observing various behaviors and things, and accordingly our designs are getting improved. So although that you are seeing that the values are not correctly displayed or all that, so we are perfecting all that now. So in fact, shortly when you will see in some in coming days, everything will be taken care. Yeah. Thank you. So I think queries and all that. Yeah, please.
This dashboard is very complicated. I don't know how many of you will be able to operate this dashboard. I think this needs to be simplified. It looks it's only for doctorates and PhDs. People like me cannot operate. So I think it needs to be simplified. That is the first observation, sir. The second one is, these values. I think you have clarified it already, so it should not be a problem. And third one is, how vulnerable are these sensors to these variations of your ground level use? Because I have worked in this national hydrology project of Government of India in water resources sector. All these water level recorders, all these digital water level recorders, we failed them very badly within even 1 month or 2 months, or even after a slight flood, because it's not that they are not unprotected. They are kept inside a concrete well, and the water is allowed to flow through the well, and the levels are supposed to be maintained and observed. There also we found that these get choked, so much of silt comes, it stops functioning. How would you ensure that these are not vulnerable to such, variations, field level variations? Some aspect you have already explained, but in detail it will be good. The fourth one is, how many sensors as a field engineer I need to put? For example, if I am an executive engineer on ground, and if I have a network of, let's say, 25 kilometers in a village, right? In a big village, let's say, how many sensors, chlorine sensors I should put at what level? Like, two chlorine sensors, one chlorine sensor per kilometer, or what it is actually? Can we have some correlation, or will it depend only on field data? You have to first study that and then you have to give. What is that, the thumb rule that will tell people to have the number of sensors? So these are some of my queries. Thank you.
Yeah. If I'm right, Murli sir. Yeah. Yeah, I'm very right, because we all know how closely he was involved with us while we created the project document and all that. And thankful to him and glad to see him here. Sir, you said, pointed out very correctly that as far as the user friendliness is concerned, our team is working, and they will take it forward, because we all are aware is how is the interface of the Apple phone. It is not as user friendly as the Android phone because of the security and aspects and all that. So I think our team is going through that. We have established all the security protocols and all that. As far as the user friendliness is concerned, we'll consider it, and they are already working on it actually. That is one point, sir. And second, you talked about the sensors, how vulnerable the sensors are. Each sensor, in fact, I didn't get much time to explain. On each sensor, I created a operation and maintenance guidance also. I have good videos also, and in the text form also, I have drafted various points. After all, because even if it is human being, how rugged we are, we also fail. Okay, हम भी बीमार हो जाते हैं. Sensors also, they have to be operated, and they have to go through a typical conditions, operation and maintenance and handling and all this. So now, as far as the deployment is concerned, of course, the team is taking care and building all that kind of enclosures, mesh and all that, mechanical enclosures, electronic related things, auto cleaning mechanisms, etc., etc. then depend upon the water quality and all that. So depending upon the water qualities, outdoor environment, etc., the failure and vulnerabilities depends upon. And that is where our data analytics will play very, very important role. So in terms of hardware, in terms of software, in terms of the data analytics, we'll be able to know all the descriptive statistics, we'll be able to know the alerts, warnings, what is happening with the particular sensor, is it an alarming situation, is it working properly or not. So this is a kind of paradigm shift now, because live we will be know what sensor is performing and how it is correct or not correct, because now आपने देखते ही बता दिया कि इसका pH का गड़बड़ है. So like that. So we are taking there's a multitude of approach that is now we are following. There is no silver bullet to solve all the problems. So we are having multitude of approaches, innovations in terms of the packing of the systems, mechanical, electronic, and data analytic aspects. And then of course the fourth thing comes is that I would have shown you some of the good videos, even the foreign makes and those who are already using the foreign make sensors. They are also vulnerable and they also go down if we don't have the operational maintenance schedule. There is an operational maintenance schedule which is to be followed, and there is a frequency to be followed either biannually or annually. So these are the aspects. Our manpower also need to be getting trained also how to handle this kind of new technologies. कितना भी automation हो जाए लेकिन human intervention उसमें आना ही पड़ेगा. AI भी हम कर ले सब कुछ लगाने के बाद में भी human intervention and human care will be definitely. So I think human driven technologies we are talking about. So ये aspects सर एक हो जाएगा. और एक आपने पूछा था, I'm forgetting operation. हाँ, yes. Here again, sir ने बहुत अच्छा क्वेश्चन किया, and while we visited various sites, what happened was residual chlorine sensor के ऊपर बहुत सारा ये होता था, क्योंकि है अच्छा सोर्स पे लगा दिया, आउटलेट ऑफ द एसआर पे लगा दिया क्वालिटी सेंसर. व्हाट अबाउट द टेल एंड, क्योंकि वहाँ जाते हैं तो मेन तो वही है, हमें वही देखना है कि वहाँ कितना पहुँचा है. So all right, there are always limitations in terms of the cost and all that, because chlorine sensor costs very high. So chlorine sensor वहाँ के बाद में, of course, why we do chlorination, everything we know, that chlorine dosing, auto dosing, and all that also is a part of the game and the system automation. There is a rule that will be evolved once we have data analytics. So once सर हम ये सब पूरा पैटर्न्स लर्न कर लेंगे, सर knows very well, जब हम ये पैटर्न्स लर्न कर लेंगे कि यहाँ पर 0.8 1 ppm का डोजिंग किया था, 2 ppm का था, वहाँ उतने किलोमीटर तक जाने तक कितना रह गया. So and pipeline क्या था, उसका composition क्या था पाइप का, and all that over a period of time, seasonal variations, etc., etc. So all the dimensionality will be taken into account, multivariate analytics will be performed, and then definitely, sir, there will be a solution. And this is what I answered when the state authorities or state concerned representatives had interaction with me, that why don't we put it there. मैंने कहा कि मुझे थोड़ा सा टाइम दो, मैं डेटा एनालिटिक्स ये सब लगा के प्रॉबेबली आपका खर्चा बचा दूंगा कम कॉस्ट इफेक्टिवली, बिकॉज वी आर गोइंग टू डेवलप एफोर्डेबल सॉल्यूशंस कि वहां पर भी हो जाएगा. एंड वेल अभी जब हम इंडिजिनेशन कर लेंगे तो हो सकता है मैं जितने मर्जी जगह लगाना है वहां लगा दूं, क्योंकि 1 लाख की जगह मैं उसकी कॉस्ट लेस देन 50,000 करने वाला हूं. सो दीज आर ऑल द पॉसिबिलिटीज सर. या स्टेट सॉफ्टवेयर के लिए मैंने जैसे बताया कि CSIR is also interested by the NJJ my responsibility to come out with a kind of reference handbook on standardization in terms of all key research vectors, sensor system, IoT, cloud and data analytics. तो वो फॉर्मेट हमें फॉलो करने पड़ेंगे, तभी जाके हम वन कंट्री वन प्रोटोकॉल का जो है ये basically we'll be able to attain it. Otherwise, yesterday also one of the speaker responded in the same way that it will be difficult because different states are going with the different things, and that is why here in the role comes in that the benchmarking site that we are talking about, 25 or 100 benchmarking site in each states, so that each year then जो tendering process से आप करोगे, upskilling industrial collaborators वहाँ करेगा, they will follow all those standards, and it will be one country one protocol. Thank you.
One more, just on the chlorine sensor, you have said there is a membrane, and it was mentioned in the slide that it needs to be changed every 6 months actually.
Okay.
So again, that would be sort of a, is that, 6 months is slightly a shorter period. It is possible for having a longer period of time. I think that was shown there in the slide. And second thing is, many of the states are now going towards silver ionization as the disinfection technology, especially states like Madhya Pradesh. They have gone ahead and then set up a lot of silver ionization disinfection technologies. So they are moving away from chlorination actually. So what would be so do we need to develop a new sensor for silver ionization methodology? These are the two questions.
Yeah. Just give me 1 second. Chlorination की जो हमने बात किया था. So This is one of the imported sensor which shows, I think this will answer your question. Just it is of, I think 3 minutes.
Hey, I'm Teresa, and I will show you how to carry out the maintenance of our digital free chlorine sensor MemoSense CCS51D. With the CCS51D, you can reliably measure free chlorine in different water applications. And thanks to the easy maintenance, the sensor has a very long lifetime. In standard disinfection applications, maintenance is required once per year. Please remember, always wear your personal safety equipment before you start
Once
to
per
work.
year in this
Safety
case.
glasses and chemical-resistant gloves. For the maintenance of the sensor, it is recommended to use the maintenance kit. It contains 2 membrane caps, electrolyte, and a kit instruction, which explains the maintenance steps in detail. Besides that, you just need a soft sponge or a tissue to clean the sensor. The maintenance is done in the following sequence. First, clean the sensor, then unscrew the old membrane cap. Fill a new membrane cap with fresh electrolyte, screw on the freshly filled membrane cap, and reset the electrolyte counter. Then calibrate the sensor and, if necessary, readjust the measuring point. Okay, let's start with the maintenance. First, remove the sensor from the process. To perform this action, set the transmitter on hold and shut down the water flow. Then you can take the sensor out of the assembly. Clean and dry the sensor and disassemble the membrane cap. Drain the old electrolyte and dispose the old membrane cap. Clean the gold electrode with a soft tissue and flush the electrode body with demineralized water. Now replace the membrane cap and the electrolyte solution.
Yeah, so I just wanted to show that all these sensors, they have their inherent characteristics on which it works. किसी भी चीज से हमें अच्छा फ्रूट लेने के लिए उसकी प्रॉपर मैन्यूरिंग करनी पड़ेगी. इफ यू टॉक अबाउट एग्रीकल्चर, तो सेम वे सेंसर से अच्छा आउटपुट आने के लिए वी विल हैव टू टेक केयर ऑफ इट. हमें उसका मेंटेनेंस जो है चाहे ईयरली वंस रिप्लेस करना है, ईयरली ट्वाइस, दैट डिपेंड्स अपॉन किस टाइप का मेम्ब्रेन एंड ऑल दैट, एंड क्वालिटी ऑफ वाटर एंड ऑल दिस एस्पेक्ट्स. तो ये सब प्रिवेंटिव मेंटेनेंस, डेटा एनालिटिक्स से भी आपको अलर्ट्स अपने आप आ जाएंगे. देयर इज नथिंग मैन्युअल लाइक दैट. मैन्युअली नहीं होगा, सब कुछ ऑटोमेटिकली ऑपरेटर्स को पता चल जाएगा, बट आवर टीम नीड टू बी ट्रेन्ड. दैट इज द पॉइंट. थैंक यू. एंड यस, सेकेंडली आपने जैसे बताया कि हो सकता है हमें वो दूसरा डिफरेंट टाइप का सेंसर बनाना पड़े.
Sir, you have mentioned that data exchange formats have been frozen. Earlier, the expert technical committee has also shared some reference guidelines for taking some reference data formats. So, what data formats should we use to while inviting the tenders to ensure the uniformity and interoperability?
या सो वन थिंग इज, एक गाइडेंस हमें गाइडलाइन मिला हुआ है फॉर्मेट का, बट पॉइंट इज नाउ इम्प्लीमेंटिंग इट इन दैट स्पिरिट एंड लेटर. सो दैट थिंग, वन थिंग दैट वी आर डूइंग. एंड सेकेंडली, इंटर ऑपरेटेबिलिटी के लिए मैंने जैसे डिफरेंट लेयर्स की बात की, फर्मवेयर के अंदर इंटेलिजेंस डालने की बात की, सेंस मेकिंग की बात की, डिफरेंट सेंसर्स में, गेटवेज में, क्लाउड्स में एंड ऑल, डैशबोर्ड्स वगैरह में. तो उसके लिए भी एक यूनिफॉर्म स्टैंडर्डाइजेशन होना पड़ेगा. उसी के लिए एक काइंड ऑफ एक एजेंसी चाहिए जो कि ये सब स्टैंडर्डाइजेशन करेगी. एंड सो एज आई सेड, शॉर्टली CSIR is going to come out with that kind of standardization of the handbook in terms of calibration and all this.
Sir, another question is, you have mentioned something about risk PyNet development. Is it under development phase or finalized?
रिस्क पाइनेट काफ़ी एडवांस लेवल पे चला गया है. And finally, but now we have to prove it in the rural sector and all these kind of footprints जहाँ पर large scale networking है. So इस type के network में जब उसकी field testing होगी, तभी जाके उसको हम जो है जिसको हम बोल सकते हैं पहले beta testing कर ले, beta testing के बाद में उसको हम deployment के लिए release करेंगे. So we are at a very advanced level there.
Thank you, sir.
May I add, Dr. Baban Kumar?
Yeah, Dr. Abha, please respond. Meanwhile, I think our team is there at a remote end. They will be also able to take your questions. So, Dr. Abha, please go ahead.
Thank you. Thank you, Dr. Baban Kumar. Risk Pilot, I am Dr. Abha Sargaonkar from CSI Niri Nagpur. We have this Risk Pilot software for pipe condition assessment and contamination risk assessment. It also gives a replacement planning, which pipes are in a high risk of vulnerable to fail and contamination risk because of sewers and open drains, and which need replacement on priority. Then considering the material of replacement and which pipe material one wants to select for replacement, it also gives the cost module, gives the cost estimation of the replacement pipes. So this is we have tested in Nagpur and in many other district metering areas of Nagpur, Hyderabad, Amravati, and it is we are in the stage of licensing also. Recently, we have floated expression of interest for if any municipal corporation or any local body wants to implement it in the cities, urban areas, or if the data is available in GIS formats, then as well in rural areas. So that is the status, sir. Thank you.
I have a couple of questions, Dr.
Thank you.
Baban Kumar. Firstly, I would like to thank you for the wonderful presentation that you made.
Thank you, sir.
Regarding the water quality index, have you already started working on it? Because either you look at, for example, some principal component based approach or some conditional variance based approach. So have
Yeah.
you worked on that already?
Yeah, sir, one of my postdoc recently started working in this, and we have completely now surveyed and done the landscaping of complete IPR in this direction from across the country, because this is something which is a country specific also, water quality
absolutely,
index,
absolutely. There are various literatures on
various literature, and as you said rightly, principal component analysis, SVM, and deep learning and class and different regression methods also will be employing in this. So work has begun. There is no, I think there is no significant milestone that has been achieved, because ultimately that is a aggregate and index that we have, which gives a
one single
parameter which gives a sense about what is the quality of water.
Absolutely.
So the range varies from 1 to 100, and we'll have different grading in that, thresholds and grading. So अभी सर उसमें डेटा जब आएगा ना डिफरेंट इसका, so तब जाके काम अच्छे से हम बता पाएंगे next time.
May I add,
One
sir?
more thing, those RMSEs and R square values that you are showing, they're definitely very encouraging. So they are based on how many samples?
Sir, we have, because the calibration and validation, as you are very well aware, the calibration and validation, we are following a strategy of 70 as to 30. Okay, 70% training set data sets and
So
30%.
that R square is on 30%?
That R squared is actually full cross validation, I would say. So 100% what we have done, one we are keeping out, other we are sending in.
So you are doing leave one out cross validation?
Yes, that kind of. And we are also doing the complete cross validation in terms of test matrix also, that is 30% test matrix. So for example, if I'm having 0.1 to 1 ppm values, so 0.1, 0.3, 0.5, 0.7. So let's say odd one I have taken for the training, and the even one I'll take as a test matrix.
Okay, so you have done it in that
That
split.
both ways we have done actually.
Oh, that's good. Very nice result.
Thank you, sir. Thank you so much.
May I add, Dr. Baban Kumar, on the water quality index?
Yes. So I think all of you have. In fact, I'm in touch with most of the states. We can further interact as and when required, and I look forward to have more interaction, especially visiting your states and freezing your DPRs and SLSSA approval and on-ground implementation. As you have seen, now we are ready for going to the fields. So I look forward, and thanks for your patient listening. Thank you.
Thanks. Thanks, Dr. Babban Kumar sir and your team for the excellent presentation. Now I'll invite each of the three groups one by one for presenting the VOQ exercise that was given yesterday. And I'll first like to appreciate all the efforts put in by the different groups. We can see yesterday like how each of the team members were interacting with each other, were brainstorming among themselves and putting out the all the numbers in the whiteboard. So can we have a big round of applause for all the states? So we'll start with group number one. So I'll kindly like to invite two representatives from group number one, if they can come and present. So sir, just we'll like a brief presentation on the case study. Just one or two slides on the brief on the what was the case and then what was your solution. And if any challenges or something or queries you have, you can just present. Mention your name.
Good morning, sir. Good morning, all the delegates. I'm J.S. Chahal. I'm representing Group 1. The problem assigned to us was we need to devise a solution, IoT solution for village Zamori. Screen share. Please, screen share. Okay. Yeah. We need to design a IoT solution for measurement and monitoring of IoT purposes for village Zamori. Let's to put things in a perspective, let's define the problem. Village Zamori having a household size of 400 is very near to Nasik. It's a peri-urban area and it's drawing water from the river Mag. Then we have an intake plant over here. Then since it is a surface water-based scheme, water treatment plant is there. After water treatment plant, treated water goes to water reservoir. Then it's fed to overhead tank. From overhead tank, it is distributed to 4 district metered areas, DMA1, DMA2, DMA3 and DMA4. All DMAs are having a distribution network of size 50 mm. So we have 3 branches in each DMA of size 50 mm. So all the households are at the same level, same altitude. So from engineering perspective, we have an intake plant, then a water treatment plant, then water reservoir, overhead tank, then distribution network ranging from the size of 150 mm, then reduced to 75 mm, then to 50 mm. So we have worked out all the 3 solutions. For basic, point of interest is intake pump chamber. We need to measure quality as well as quantity. Then similar interest is also there in water treatment plant, wherein we have also measured quantity as well as quality. In water reservoir, we need only sensor for measuring level of water. Similarly, in elevated service reservoir, there is a level controller device. From level controller, from outlet of OHSR, we have put up pH sensor as well as the chlorine analyzer. So we stopped over here for the basic purpose. In terms of intermediate solution, we entered into DMAs. At the entry point of each DMA, we have installed a flow meter of size 75 mm, and we have also installed three flow meters of size 50 mm in each of the DMAs. So in advanced system, what we have analyzed is we replaced these 50 mm size meters with the household meters. All other components of this intermediate system has been retained. So these were the key objectives. All the habitats are to be ensured to be getting enough water supply of approved quality, of approved quantity. Then whether all the supply hours are as per schedule. Then tail end pressure is agreeable. Water quality as well as quantity is of prescribed norm. Chlorine level at the tail end, satisfactory performance of pumps. Then some measurement about energy conservation, reduction in water losses, improvement in consumer grievance redressal mechanism. So we have worked out, these are the details. Going by these, as I explained earlier, we comes out to this cost analysis. For basic, we have figured out 3.56 lakh as capex, which comes out to be 1.18% of original cost, which amounts to be 300 lakhs. In terms of intermediate, capex cost was of IoT solution is 10 lakh 26,000, which comes out to be 3.42% of original project cost. It's well within the original limits. So O&M cost in this case comes out to be 76,000 per year. In our advanced system, capex cost increased to around 20 lakhs, which comes out to be 8.42 lakh. Though these are urban settings and consumers can pay, but I still figure out this model will not be sustainable in terms of high O&M cost. It comes out to be 2.27 lakh per year. Going by the household size, even 100% consumers are paying their bills at 100 rupees. Revenue recovery will be around 5 lakh, and 50% is going to this is not a recommendable model. So I will suggest intermediate model. So recommendations are intermediate solution, intermediate IoT solution, which is a cost effective and it fulfills almost all the objectives, and it has a O&M cost low as compared to advanced model. Thank you. Thank you all. Anything from my colleague?
This is what all calculation what we did based on that. It's okay. You have covered all points.
Thank you. Any questions or comments, please? Thank you. Thank you very much.
Thank you, group number one. I think this was fairly accurate. What is to be noted is basically what Pradeep Singh sir was saying yesterday. What is the percentage cost of the total key scheme cost? As you can see in basic, it's around 2%. In intermediate, it's around 4%. Of course, it can vary. In scheme to scheme, you may have more meters in intermediate as well. And in advanced, it's nearly 10%. So that is the range where we are looking upon, and it should not go way beyond these ranges. So it's a fairly accurate exercise by group one. Thank you very much. And we welcome group two now, representatives from group two. You shared over WhatsApp, no? Just hold on.
Okay. No, anything technically they want to edit. Can intermediate somebody have to come, sir. I'm not work. Who is that? Where is he, Rupit? That you will explain for me.
Please be there. Please be there.
Because the DMA is thing which we discussed yesterday. Yeah, that's one. That I've written, I think. First, you can show them now.
So this is a map, okay? And this is a group two presentation.
Yeah.
This is a presentation.
Yeah.
And I'll open the photo for you.
Yeah, map they have taken it. And
This
then
is
Excel sheet intermediate also he has taken it. Intermediate also you have taken it.
this is a map, right? For you.
And then
This
presentation.
is a presentation.
And then
this
this
is
is
a
intermediate.
this Excel sheet, right?
Mm.
It's taking some time to load.
Can I forward again?
No, it's there. Excel is not open. This is not open. This is the one, right? Excel টা খুলছে না।
So good morning, actually. So I'm Subha from IHS Bangalore. We are the Key Resource Center for L1 and L2, and we working on water supply implementation project in Karnataka and sanitation in government of Tamil Nadu. It's very nice that 2 days we have heard about IoT and what is exactly the consequences. Like a lot of when we went for training, people asked a lot of questions on the cost, how it works, robustness, sensors, how I change. And the big question with us that we have to train the VWC committee, how they are going to hold this scientific to them. So this is one of the queries they are asking. I felt it's a very realistic when we attend this program. We have a group 2 and we had more than 25 people. I'm not aware of all the people. And so we worked it a second group. There is a case study which names on, it is in the one of our districts in Rajasthan, Pirohi, and Gabat village is given to us. The significance of this village is there is a 75 lakh population and 100 households, and it is a groundwater based water schemes. This 3 is a significant part in this, and they have given one of the conditions. The electric city supply is an intermittent, and there is a frequent power cut. So it's understand there will be a frequent power cuts, and also they have also given that cellular connectivity of 3G is not up to the mark. That means we have to take as a 2G. 3G is not there, still we get an implementation. So these are the significant point which we noted from the case study. And this is a layout which they have given to us. The H17 and H29 are the upward slope, and H29 having the highest elevation, and 54 to 100 or downward slope, and 100 have the lowest elevations. So this is actually we divided, and it's a very simple thing, and they are using on the 75 pipeline, and also in the distribution network they are using 50 Our group have been targeted to do only basic and intermediate, not an advanced, because we understand that basic and intermediate, if it works, then we go for advanced. So that is the realistic we work for too. And already in Annexure 1, they have given clearly that what are the sensors we required, what is the point we have to do that. So I'll present on the basic first, and then I'll move on to this one actually. Sorry, it's only my name, other name I could not roll out, that's why I could not do it. So we got this system like BOQ yesterday. So for that, we have been doing, it's a 75 dia. So bulk flow meter, we been doing one quantity size, and it is 17,000 cost. And we have a ground level sensor, which is also required for this. And we thought that ESR level sensors, and actually PLC is not there in this basic model, but we took the amount in that 15,000. And as you said, whether it's a basic or thing, one chlorine sensor is a significant aspect. Full screen. Sorry. Okay. So the chlorine sensor is a significant aspect. So we use that as one, and turbidity sensor one. And being a 2G category, we only go with a GSM. We don't want to go for other techniques on that. So we limited us in that level. And solar panel, solar panel plus batteries. We thought 3 as per the norms, and each cost the 3,500 because electricity supply is an intermittent and it's power cut. So solar is one of our viable solutions which we thought to do it. And exclusively when you're training for VWSC committee and everything is a visual dashboard which you gives the decision making clear. So whether it's a basic or any other thing, the display is required. So we took that 32 inches a significant aspect. So the total capex works towards as is 1,51,500. And when we put the device supply and installation as per the case study which they have given on the 15% of a capex, it is coming around 22,725. GST is 18%. And total installation cost with this GST, it's coming 49,000. And O&M cost, they told us 10% capex, so we took us 15,150. So total cost of the, only on the basic model is 2,16,1645. Okay, it's 2,16,000. If it's a project cost, is 75 lakhs. So if you put in a percentage, it is coming around 2.88%. So we are near to the group 1 also. So I agree that around 3 lakhs comes. But one of a point, after hearing 2 days, I also felt yesterday I missed in the group that we also want to exclusively put the vendor cost in this because 3 years you're going to give the O&M for them. So the replacement of the sensors, all the cost, whether it will be meet within the 15,150 is going to be a question. So that is one realistic figure we want to ask from the vendor, but 2.8% is coming on this. So this is our basic model, which we worked on that. And there is another model, which is like intermediate. They have given us a Excel sheet. So sorry, this is Excel sheet. So because in 55 bulk flow meters, we have 4 because we divided the map. That is, there is a 4 type of branch out is there. So we given as a 4 DMA we created because it's a particular zone of that. So that's why we have a 4 and 1 bulk flow meter. Ground flow level sensor is 1, and then ESR level. It's very significant that PCU is required here. And chlorine sensor we put 2 because it's one of the source level. Another one is on the tail end level. pH sensor, it's 1. Turbidity we put 2. I want to understand why that's 2 because somebody can explain me. Pressure sensor, which is 1, and gateway, other things is there. Solar panel, we have a 6 because we have divided as a 4 gateways, 4 DMA level. So yesterday, Mr. Girish was helping us, then he was telling that the power requirement of this particular ward, it is this much watt. So whatever the electricity intermittent you are getting in this power supply, it doesn't work. So you have to have this grid, this grid doesn't support. So that's why we have worked out for the 6 solar panels. And then display unit is 1 and RTU is 9. Can kindly sir can explain on the turbidity meter and RTUs of that. So why they have given 9, actually at what point? And the turbidity sensor 2, they have given it. 1, no? Yes. Okay, sorry, it's like mistake. It's typing mistake. And regarding RTU.
With each that sensor, with each sensor we are giving 1 RTU. That's why it has been taken 9 because 9 sensors are there. So we have taken that 9 RTUs for 9 sensors. As discussion with Mr. Girish, yeah, you can make it 1 only.
Yeah. This is turbidity is 1. Sorry that it has printly. So it's coming around 4.4. It's coming around 4. That is the percentage of intermediate is coming around the 4.4 percentage. 4.49 percentage. That means it's included a group 1 and B are in a same target. So the double time the cost of basic to the intermediate. So this is a group worked. So thank you. Around 6%. Around 6%. Around 6%. No, the Excel sheet gives its. Yeah, that's all. Okay. That is clear. So this is actually it's 1 0 is missing and 1 into 1. So this we have worked out. So as far as it is coming out. So this is our model for basic and intermediate. Thank you. Batteries also. Yeah, included. The cost of this they have given in VivoQ is solar panel plus battery is 3,500 they have given. So that we worked into 9, the actual cost.
Hello. So we see that you have flow meters and ground. What is the rationale of having a ground level sensor? Why we had it?
1 minute, sir. I'll open. Because it's a groundwater based scheme. So we want to know the quality of that, the level also.
In which area? What was the geographical location of the village? Which state, let us say?
It is Rajasthan.
So since the groundwater is an
Yeah,
issue,
issue
sources dry up. So for the audience, I think it is important that they get it. We need not have groundwater sensors everywhere. Okay. Now let's go back to the Excel sheet. Yeah. Correct. Then you have flow meters, bulk flow meter for each zone, and 75 bulk flow meter for one line that we have in the network. And then you also have a gateway and display unit. And what is the communication system that we will use?
LP.
So it is included, that cost is included in that?
Yeah, sir.
Acha.
They have given
So the devices will communicate to each other using LPWAN network protocol. Okay.
for basic we use GSM, but here we cannot use it because it's all the DMA has been centric. So that's
And here we assume that the data center is provided by the state government and it is available. So therefore the cost is not included, isn't it? Okay. So very good.
Thank you, sir. Thank you.
With LPWAN, shouldn't there be a GSM device or a Wi-Fi device also to communicate with the external network?
Actually, after Mr. Baban's presentation, we understand that he has given the comparison between the Wi-Fi and the things. So we want to use it yesterday. We don't know about that. So probably that cause we have not done it. So the person who have prepared the intermediate is coolly sitting there actually. So you can comment.
So basically in the LPWAN,
Uh,
we establish a private network infrastructure. So like all the slave nodes of the RTUs will communicate to the gateway at 868 megahertz. That is the ISM free band used for data transmission. And at the gateway, we use one cellular network to transmit the data to the server. So for each device, you don't need GSM RTU. It is basically LPWAN, that is a sub-gigahertz RTU. That could be your LoRa, Sigfox, or NB5. Any technology you can use, but it is all sub-gigahertz.
where it's here, the intermediate one. Yeah, it's wrong actually.
Actually, it's GST. It's not only GST. It's installation, shipping,
Installation, everything he
and
has written.
annual O&M.
Here we have given clearly, like this, all the cost he has put to that 1.29. Here we have, for basic, we have given like this, but yeah, here for basic, we have given this, but all these put together, it has given, sir, but that has mentioned as GST in intermediate. But after doing this exercise from our end, the communication layer should be deep downly understand by the people, because we go with the BOQ, ek one lagega, one solar made two, what is the frequency, but the region specific, the bandwidth, how the RTU supports, whether Wi-Fi, I felt that part, otherwise we know sensors is one and whatever it is, but that type has to be clarity towards the down level so that they will work in most of this. It feel difficult, as Grish told us, each one we had this, otherwise we have given like 3 or 2, whichever we know that. So I felt this area of communication layer should be very explained to the deep root so that we understand the designs. That's one thing which we felt when we are doing the exercise. So thank you, sir. Thank you for that.
Now I'll invite two representatives from group 3. AO, SPM Newas, AO, SPM, NIWAS, at gmail.com. Gmail.com. I'm also logging. इसमें तो कर दिया मैंने एक आ गया सर। आ गया सर। हाँ जी वाटर तो दोनों दे दिया। ठीक है सर डाउनलोड एक बार देख लीजिए पहले स्केच आएगा sketch this one is this is what एक ये आया है एक ये आया है दिस इज द वन ये बेसिक वाला है हाँ ड्राइंग ड्राइंग देख लेता हूँ सबसे पहले ड्राइंग देख लेता हूँ ठीक है मैं देख लेता हूँ ये समझ लिया दिस इज द ड्राइंग ओके और आपका एक प्रेजेंटेशन था वो दिखाना है नहीं है ना ये प्रेजेंटेशन तो नहीं है नहीं है फ्री है ना नहीं कोई प्रेजेंटेशन नहीं है ना ये डाउनलोड नहीं हो रहा है एक ये फॉर्मेट में था पीडीएफ ये चलेगा वो भी चलेगा आपने भी जो बताया था याद है चलेगा आपने जो बताया था ना वो इससे चल जाएगा चल जाएगा मैं देखो zoom in तो नहीं हो रहा ठीक है इससे चला लेता है याद है ठीक ये डाउनलोड खुल नहीं रहा है इसमें सॉफ्टवेयर नहीं इससे चला लेते हैं यहाँ पे दिखेगा फिर से भेजो ना ना ठीक है यहाँ से इससे हो जाएगा ना यहाँ पे दिखेगा हाँ यहाँ पे दिखेगा ठीक है तो ठीक है यहाँ दो डॉक्यूमेंट है पहले वो दिखा ड्राइंग ड्राइंग ना जूम इन नहीं हो रहा है इसको एक सेकंड एक ड्रॉप एक सेकंड ना ना ये नहीं ये है ना ड्राइंग स्क्रीन and these are the documents ठीक है ओके तो तीनों ओपन इट ये ओपन कर दिया ये ओपन ठीक है ये दोनों बाहरी है हाँ इसमें आप जैसे इसको मिनिमाइज कीजिए है ना ओके बाहर है तीसरा है इसमें है ये इसमें बिंग में है दोनों ठीक है आपका दो डॉक्यूमेंट और ये आपका पिक्चर है यही था ना ड्राइंग तीनों यहाँ डेस्कटॉप रख दीजिए नहीं हो रहा है बिंग हो रहा है आप यहाँ से ऊपर कर लीजिए ठीक है जल्दी इसको मिनिमाइज कीजिए ओके ये पहले ड्राइंग के लिए ड्राइंग उस पर यही ड्राइंग है ना हाँ मैं उस पर आ गई शेयर
सभी को नमस्कार। हम लोगों को ग्रुप नंबर 3 में रखा गया था। जो प्रॉब्लम हमें केस स्टडी दी थी वो एक उत्तराखंड के उत्तराकाशी के गुंडी गांव का दिया था जिसका एल्टीट्यूड 1550 मीटर सब काफ़ी ऊंचाई पे 1550 मीटर एल्टीट्यूड है उसका, और वहाँ 100 घर थे। उसमें इलेक्ट्रिफिकेशन 100% हो चुका था, लेकिन इलेक्ट्रिक पावर कट काफ़ी ज़्यादा है वहाँ पे, और 3G का नेटवर्क भी वहाँ पर नहीं आता है, और हिली टेरेन होने और रिमोट एरिया होने के कारण से वहाँ पे काफ़ी चैलेंजेस हैं। और ये माना गया था इसमें कि विलेज इंफ्रास्ट्रक्चर में 100 लाख मीन्स 1 करोड़ रुपए खर्च होगा, और गवर्नमेंट चाहती है कि इसको एक मॉडल के रूप में बनाया जाए इस गांव को, जिससे कि दूसरे गांव भी इसको देख सकें। तो हम लोगों ने इसमें बेसिक में लिया है, और एक इंटरमीडिएट की स्टडी की। इंटरमीडिएट में भी हम लोगों ने, क्योंकि फ्लो मीटर भी इसमें हमने इंटरमीडिएट में लिया है, क्योंकि मॉडल विलेज बनाना है। तो कंज्यूमर फ्लो मीटर जो हर घर में लगने हैं, सो कंज्यूमर फ्लो मीटर, वो भी हम लोगों ने इसमें इंक्लूड किया है। तो हम लोगों का जो मेन इसमें जो था वो वाटर सप्लाई हर आदमी को मिलना चाहिए। इसमें अभी ऐसा था कि पानी तो सबको, पानी सप्लाई सब जगह हो रहा है, लेकिन कहीं लो प्रेशर के कारण से नहीं हो पा रहा है। जहाँ ऊंचाई वाली जगह पे उनको मोटर लगानी पड़ती है, और कुछ जगह पे प्रेशर का इशू है। तो जो इसमें हम लोगों को करना चाहिए था, उसमें एक वाटर सप्लाई सबको मिलना है, और बराबर क्वांटिटी में मिलना चाहिए। टेल एंड प्रेशर एग्रीएबल होना चाहिए। सप्लाई आवर्स जो है उसी एज पर शेड्यूल होना चाहिए। वाटर कट का मतलब उसमें इफेक्ट नहीं आना चाहिए, और वाटर क्वालिटी इज एज पर प्रिस्क्राइब नाम्स होना चाहिए। क्लोरीन लेवल जो है टेल एंड पे एग्रीएबल होना चाहिए, और वाटर लॉसेस कम होना चाहिए। इसको देख के हम लोगों ने एक बेसिक का बेसिक इस पे बनाया है, और एक इंटरमीडिएट पे बनाया है। मिस्टर चावड़े बताएंगे।
सर बेसिक में हम लोगों ने एक फ्लो मीटर लिया है, जो ड्राइंग में आपको दिखा। एक सर फ्लो मीटर है जो 75 mm डाया की जो पाइपलाइन जो निकलती है मेन, उसमें एक लगाया है, और 50 mm डाया का जो एक फ्लो मीटर लगाया है, वो जो अपवर्ड स्लोप है उसके ऊपर हमने लगाया है, ताकि जो डिस्टरबेंस होता है, जो पानी नहीं मिल रहा है, वो एक्चुअली वहाँ पर है, इश्यूज है। फिर एक क्लोरीन एनालाइजर लगाया है, एक टर्बिडिटी सेंसर। टर्बिडिटी सेंसर इसलिए लगाया है क्योंकि ये स्प्रिंग जो है, पानी जो है वो स्प्रिंग से आने वाला है, और मानसून के पीरियड के दौरान इश्यूज रहते हैं टर्बिडिटी के, इसलिए वो लगाए हैं। फिर सर्विस लेवल रिजर्वायर में एक लगाया है, और एक रिमोट। तो टोटल सर हमारी जो कॉस्टिंग आ रही है इसमें बेसिक्स में, वो 1,24,000 हो रही है, और इंस्टॉलेशन चार्जेस और जीएसटी मिला के कुल कैपिटल कॉस्ट हो रही है 1,68,000, यानी तकरीबन 1.68% हो रही है बेसिक में, और उसकी O&M कॉस्ट 10% के मुताबिक 16,830। और सर इंटरमीडिएट भी।
बेसिक में किसी को कोई सवाल हो तो आई थिंक वी कैन आस्क, जब तक कोई इंटरमीडिएट दिखा रहे हैं। एक सवाल मेरा है कि इसमें 2 फ्लो मीटर क्यों लगाया आपने बेसिक में, 75 डाया वाली पाइप पे भी और 50 वाले पे भी?
50 वाला जो लगाया है
वो
वो जो
नेटवर्क डायग्राम एक मिनट दिखाइए।
ये जो सर अपवर्ड स्लोप वाला जो है, उसके ऊपर वहां पर एक्चुअली पानी की क्राइसिस है, पानी नहीं मिल रहा है, तो उसके ऊपर लगाया है कि इश्यूज क्या रहते हैं, कितना पानी जा रहा है। बाकी तो जो है वो फ्लैट रीजन है, दो दो साइड जो है, और एक जो है वो डाउनवर्ड साइड है, उसमें तो मिलेगा ही मिलेगा, लेकिन जो अपवर्ड है वहां पर नहीं मिल रहा, इसलिए बेसिक में वहां पर लिया है।
वहां से ज्यादा कंप्लेन आती थी, तो उस
हाँ,
कंप्लेन को सॉल्व
कंप्लेन
करने
को
के
सॉल्व
लिए
करने के
और
लिए।
इंश्योर करने के लिए कंप्लेन सही
Yes.
है नहीं सही है, आपके एंड पे आपने एक फ्लो मीटर लगा दिया। गुड।
यस। अच्छा, इसमें बेसिक में तो नहीं लिया, इंटरमीडिएट में हमने लिया है। इंटरमीडिएट में हमने लिया है
पहले भी सवाल था बेसिकली कम्युनिकेशन में, जो द फर्स्ट माइल कनेक्टिविटी, अगर नंबर ऑफ मीटर्स ज्यादा हो जाते हैं
अगर नंबर ऑफ मीटर्स दूर दूर है तो फर्स्ट माइल में हम लोग एलपी वैन यूज करते हैं। अगर कम है बेसिक में मीटर्स कम रहते हैं नंबर ऑफ डिवाइसेस, तो हम डायरेक्टली डिवाइस से जीएसएम यूज करके हम लोग क्लाउड पे डेटा भेज सकते हैं। तो यहाँ पर आई थिंक आपका 1 मीटर ज्यादा हो रहा है जो थोड़ा दूर है, ठीक है, तो इसलिए आपको एक आरटीयू यूज करना
पड़ेगा। ओके।
हाँ, तो क्योंकि वो 50 में आइडियली बेसिक में वो नहीं रहता है, 50 एक ही मीटर रहता है,
ओके।
तो एक आरटी यूज करना पड़ेगा। तो गिरीश, इफ यू वांट टू ऐड एनीथिंग।
Only 2 clusters.
दो का क्लस्टर है।
So we can go with the 2 GSM modules. So one GSM module, which will cater to all the devices near the ESR.
Yes.
And one separate for the H17.
दो GSM मॉड्यूल चाहिए हो। अगर हम सेलुलर टेक्नोलॉजी यूज करते हैं, अगर एलपीओ यूज करते हैं तो 2 आरटी एलपीओ करना चाहिए। बट यहाँ पर बेसिक है तो सेलुलर कर सकते हैं।
ओके।
तो थोड़ा कॉस्ट पड़ेगा।
ओके। नेक्स्ट है। और ये सर हमने इंटरमीडिएट के लिए किया है। इंटरमीडिएट में हमने 3 फ्लो मीटर लिए हैं 50 mm डाया के, और जो हाउस होल्ड हैं 100 हाउस होल्ड, वहाँ पर हमने पूरे ले लिए हैं सभी जगह। फिर ग्राउंड वाटर लेवल सेंसर की तो जरूरत नहीं है, ईएसआर लेवल का रखा है और पंप कंट्रोलर यूनिट का रखा है, दोनों एक एक। एनर्जी सेंसर भी रखा है, क्लोरीन सेंसर, पीएच सेंसर, ये इसमें इंटरमीडिएट में हमने सब कुछ ये ले लिया है। प्रेशर सेंसर हमने 2 रखे हैं, एक सर रखा है ये एक लोअर एरिया में और एक अपवर्ड स्लोप में, दोनों जगह पर एक एक ले लिया है। फिर गेटवे लिया है एलपी वैन, और बैटरी ली है, क्या है कि यहाँ पर फ्रीक्वेंट पावर कट्स हो रही है, इसलिए बैटरी भी ली है। डिस्प्ले यूनिट फॉर विलेज लेवल डैशबोर्ड एक, और RTU1। टोटल मिला के जो कैपिटल कॉस्ट आ रही है वो 8,38,000, और 7% कैपेक्स के मुताबिक O&M जो ईयरली आ रहा है 67,000, यानी तकरीबन 8.38% हो रहा है।
यहाँ पर भी नंबर ऑफ आरटीयूज आपने एक लिया है, लेकिन एक से नहीं होगा।
ओके।
क्योंकि बहुत सारा मीटर्स है ना, वहां से आपको डेटा भेजना होगा एक सेंट्रल। आप जो गेटवे आपने एक लिया है, इट्स फाइन।
ओके।
तो गेटवे में कैसे डेटा आएगा डिवाइस से? वो उसके लिए डिवाइस लेवल पे आदर इनबिल्ट आरटीयू चाहिए और एक सेपरेट आरटीयू चाहिए। सो आरटीयू जनरली यहाँ पर सिंप्लीफिकेशन के लिए हमने लोगों ने इक्वल टू नंबर ऑफ डिवाइसेस हो सकता है, लेकिन जहाँ पर डिवाइसेस एक साथ नजदीक है तो कंबाइन करके एक आरटीयू भी हो सकता है। तो यहाँ पर आरटीयू ज्यादा होंगे, मतलब
ओके। तो आपके ख्याल से कितने हैं?
फॉर सिंप्लीफिकेशन आप नंबर ऑफ डिवाइसेस के इक्वल आरटीयू ले सकते हो यहाँ पर।
ओके ओके।
लेकिन वो एक्चुअल सिनेरियो में आप उससे थोड़ा कम होता है, जितना नंबर ऑफ डिवाइसेस होता है कम होता है, क्योंकि डिवाइस अगर टुगेदर विद ESR के बाहर में एक फ्लो मीटर है, उसके सामने ही क्लोरीन सेंसर है, तो आपको कंबाइन करके एक आरटीयू में हो जाता है।
ओके। हाँ हाँ।
100.
Can we meet the O&M cost from the 100 FSTC coverage? Household, if you collect the water tariff, जो भी कलेक्शन होगा, यहाँ 67,000 O&M cost per year मीट कर सकते हैं?
एक्चुअली 67,000 ईयरली है और 100 हाउस होल्ड है।
यस।
मेरे ख्याल से कोई इतना ज्यादा भी नहीं रहेगा, ईयरली है इसलिए।
वही मैं कह रहा हूँ कि सर आप मानो तो 5,000 5,000 हो सकता है।
50 रुपीज पर 50 रुपीज पर हाउस होल्ड।
नहीं, उसमें तो O&M में भी और बाकी चीज है, हो रहा है ना।
हम लोग हमारे यहाँ इंदौर जिले में 100 रुपीज पर एफएसटी पर हाउस होल्ड ले रहे हैं हम लोग जी। इसमें चूंकि ये एक रिमोट एरिया का गांव है और थोड़ा सा क्रिटिकल कंडीशंस है, इसलिए सारा पैसा उन लोगों से लेना पॉसिबल नहीं हो पाएगा। और उसके अंदर इस तरह का भी लिखा था, वो फार्मिंग करते हैं, तो बहुत ज़्यादा पूरा पैसा उनसे कलेक्ट करना पॉसिबल नहीं है एज पर IoT फॉर IoT पर्पस। Any more question? Okay, thank you.
Any other group member want to add anything or their experiences or their thing, if they can? आपके ग्रुप में और कौन कौन था?
हम लोग इसमें लगभग 25
किसके स्टेट से थे? किसके स्टेट से?
नागालैंड, मिजोरम, हिमाचल प्रदेश।
नागालैंड और मिजोरम से आपका कैसा अनुभव रहा? कुछ बोलिए। नागालैंड से बोलिए, फिर मिजोरम से बोलिए।
टेरेन तो लगभग फ्लैट जैसा है।
साथ में सर हिमाचल से भी थे और सेम इश्यू वहां पर रहता है। कल बात भी हो रही थी। कोई है हिमाचल से? कल मेरे साथ थे। हाँ प्लीज।
Sir, we are from Manipur. We also in this group, sir. But sir, my confusion is just in the discussion, we learned that every device we require the RTU. So here we are providing for consumer. Just show me this thing network. Here that we are providing consumer flow meters number of 100 numbers. So for that we require this thing 100 RTU. Okay, okay. And then, yeah, we know that this thing quality sensor, for that we require RTU also. Then this will affect the cost, this thing, component. Okay. Okay, okay, thank you.
Okay, sir. My name is H.L. Thangvuta. So one of the questions that I have is, suppose if we, in the intake, I don't think we have the network for GSM. So, but for in basic, we are supposed to use that GSM, right? So can we use that low powered WAN? I'm pretty sure that at the intake side, we are not getting the. Okay. Even if we go for basic, we need to use. Okay. Okay.
Hello, this is from Manipur, sir. I have one more question. The thing is that in hilly terrain areas, you said like the gateway will be within the range of 5 kilometers. But in hilly terrain areas where the distribution, when there is a haphazard distribution of the populations, and then in between there may be disturbance due to the hilly terrains, whether a single gateway will do or not.
Yes, that's a very good question. So yes, yeah, it may not do a single gateway since the LP WAN range varies from 5 to 15 kilometers maximum. So if your network is spread out more than 15 kilometers, 25, 20 kilometers,
No.
then
That is the habitation is within the 5 kilometers only.
then one gateway should be good
But
enough.
but in between there are like in hilly areas, the distribution is just like one from one habitations to another habitation in the same village.
Mhm.
So there is a block by the hill terrains.
Okay.
So
There we have a similar project in Uttarakhand. So
Mike.
Hello. Yeah, instead of star topology, we might have to go for multiple hop. That is, in between, we'll divide the entire zone into multiple clusters, and in between clusters, there'll be routers which will collect the data and then push it to the gateway. So it is like star of star topology.
Okay.
So that we avoid the obstacle. So basically, at the time of designing the architecture, you have to take care all this.
Okay.
Is that clear? Or?
Yeah. Okay. But the topology concepts.
So for hilly terrains, first of all, we have to design a solution which is very simple, especially in remote areas. You cannot have slightly advanced systems there. For areas which are near cities, go for communication devices and things like that. Otherwise, stick to very basic things, whether the water has flown through a pipe or through ESR or not. At least if you can ensure that, that itself is a huge, in terms of service level and customer satisfaction, you will solve 60% of the problem. So let us solve 60% of the problem first, and then go for remaining 40%, 20%. So suppose, for example, in Manipur, I have to design our this water sensor-based measurement and monitoring system. I will select those villages which have very good connectivity, very good GSM connectivity, because the remoteness is the most important and critical factor in your areas. So out of how many villages we have in Manipur?
Altogether, we are having 2,556
So
villages.
2,500, let us say 200 villages, we have very good connectivity. So in 200 villages, we use GSM and things like that. Then another 500, we have compact villages where we can go for this LoRa kind of thing. And depending upon the calculations, if it is cheap, then we take the LoRa thing also. For remaining villages, from the source or from your water treatment plant, whether everyday water is flowing or not, because at water treatment plant and your pump houses, you have the power and everything. So you measure that without any network, and at least locally people should get messages and things like that, like the system we have in Indore. So that kind of simple system we have to decide. So don't don't have everything for everywhere. Okay,
thank you, sir.
Thank you. Just one more question from Himachal. No questions, sorry.
Hello everyone. I am from Himachal Pradesh, Palampur Tehsil. Sir, in this, what I analyzed was that we need bulk flow meter at the intake because at the ESR or at the pump house, just because from the spring, sometimes we have variable discharges due to various reasons. So we need to know that what discharge we are getting at ESR, because the distance between springs and spring or the intake chamber and our ESR is certainly very long in hills. So we need a bulk flow meter at ESR, as well as where the habitation is at near those are on the upward slope. We need one chlorine analyzer, one pH sensor after the ESR, one turbidity sensors, as sir mentioned, in the rainy seasons we get highly turbid water. One pressure sensor for the upward slope. We don't need any groundwater level sensor. Service reservoir level sensor we need at the ESR, and RTUs as we have discussed. We need, sir, one energy sensors, because it is mentioned in the case study that voltage fluctuations are there. So we need energy sensors for voltage fluctuations, and inverter with battery backup, or maybe solar panels. Thank you.
Sir, I'm from Chhattisgarh. Sir, as far as that group case and group studies are discussed, and I came to know about other groups studies also, case studies. So I came to that conclusion, sir, that we need to work and we need to make more aware about the communication network, because it's a very not aware of all these things, because most of the civil engineers and those who are doing on this job. So I think from IT side, we should either we can prepare some checklist kind of thing, or we can give more exposure to these things, how to decide that communication network devices, selection of devices. So that is main that outcome what I feel from that case studies and preparation of this BOQ. Thank you, sir.
Sir, and one more thing. Yesterday, he raised a concern that he's not able to get the data directly from the gateway. It is going to the vendor and then it is coming to government server, but not necessarily. So, so that even the messaging protocol, I feel there has to be some training session or messaging protocol between the gateway and the server, so that they can choose what is the protocol they can use.
Sir, I'm from Pondicherry, sir. Regarding the data transfer from that protocol, any cyber security aspect should be involved, sir. Because that transfer data may be, security issues may be there, sir.
So those conditions are the standard for any kind of data transfer. And in the GEM RFP that you saw yesterday, it is already inbuilt. So those things are taken care. Only thing that from previous two questions, I can give some response. One thing I think you should be very clear is, I think you are comfortable in designing BOQ, how many sensors, things like that. I think that after this workshop, it should be very easy. Now, second kind of communication layer. So there at least you can have a kind of checklist whether what kind of network is available, GSM hai, nahi hai, and all those things. For remote areas, for example, hilly areas, it may happen that even LoRa connectivity from village to village may not be possible. There may be a mountain in between. So if such features are there, so that can be part of your checklist. So apart from that, I don't think any other information you need to take from the field, from our PhD engineers. Rest the solution provider should be able to design for you. Now coming to the other thing about the communication layer, cloud, and those protocols. So in the RFP document, you must have seen those standard things are provided. Once you decide your device layer, how the number of devices, and you finalize what type, whether you will need LoRaWAN or not, or you will only need GSM. So that decision, if these two decisions can be taken, rest everything I think is there. But maybe a little bit more exposure and little bit more understanding. And I think there you will, if you get this CSIR pilots done in your state headquarters, near your state headquarters, that we are chasing all the states, at least you get 25 villages up and running, then those clarifications will be there. And because this decision can be taken at a state, small team at state headquarter level, of course they should know it because they will be interacting with the vendor. But I think that should be sufficient. And the right way to go is get this 25 villages near your state quarters up and running so that you can understand these nitty-gritties.
Sir, one more question from Puducherry, sir. Sir, from the case study, it came to know that so we are basically PhD engineers, all are civil engineers, sir. From case study, it was came to know that the involvement of the IT engineers is mostly, sir, there. The cost for the involvement of the IT engineers should be added, sir. Plus other other support field persons also need, sir.
Cost of?
Sir, cost of IT engineers plus.
अच्छा नहीं तो उसमें the solution provider, the vendor that will come with you will be providing all those helps and necessary guidance. It is not very difficult. Right now you already use many softwares, so you don't need a IT person there to run that software.
So
You use
design,
that
to
software.
design what is the architecture we need, what is the LAN available, some field apart from our
For
civil field.
पुदुचेरी तो GSM ही है, उसमें कोई समस्या नहीं, क्या सोचना है उसमें?
Sir, I am not asking for only Puducherry. For all.
You do for Puducherry.
Sir, we need standardization of specifications for each item.
So yesterday, I think that is the area I think that we do some work. Yesterday you saw on the GEM portal, lot many specifications were there, but it was too lengthy and complicated.
Yes, sir.
So we will request Dr. Babban and his team to just review that and simplify that. Because for us, I think it should be the performance parameter that should be there. Whether the sensor is giving me standard error of less than 5% or not. है ना?
Yes.
Whether this input, maybe input voltage or very few basic service level parameters. I think what is the maybe the unit of measurement? Range is another very important key, from what to what it will measure. So those 4-5 performance parameters. फिर उसके बाद वो कितना milliampere current and all those things, I think that we can simply leave from the document also. So we'll take help of Dr. Babban and review that and make it very simple. Yeah, you can speak. You can speak loud, it's all right. आपके लिए आ जाएंगे बिल्कुल.
ਆ ਡਬਲ ਆਣੀ ਚਾਹੀਦੀ ਹੈ ਮੇਰੀ ਫੋਟੋ ਇੱਥੇ ਖੜ ਕੇ ਖਿੱਚੋ ਨਾ ਕਾਰਨਰ ਤੇ ਫਿਰ ਐ ਦੋਨੋਂ ਆਏਗੇ आ गई एक इधरों खिंचो इधरों इधर अब पुनीत पसीन ये देखो क्या कर रहे हैं नहीं
Request everyone to kindly settle down. One small important announcement. Before leaving, I request all the participants to collect their certificates and a group photo from the next room. The hard copy of the group photo is also available. So not now, not now, after the session ends. Kindly, okay. We'll distribute them here in the auditorium only. Case studies and all the all the presentations will be shared, ma'am. That will be shared. They can put in a WhatsApp group, or by today's end, I'll share all the presentations, the case studies, and the presentations made by the states and the groups in the WhatsApp group. And kindly settle down.
আইস্যাক যদি ওয়েট করে জিপিটা করে দিতে বললো স্যার। ওয়েবলি কেটে গেছে, তাহলে তুমি জিপিটা করে দিতে। দাঁড়াও।
है नहीं नहीं सर, उनको दे देना मणिपुर का, मैं हैंड ओवर कर दूंगा मणिपुर से। फोन तो लेना आधा लोग। টেকনিক্যাল ডিফিকাল্টি বলে জিপিটা করে দিচ্ছি। চলো অমিত আছে প্রেজেন্ট? সবাই আছে, বলে দাও। একবার দাঁড়াও, করিয়ে দিচ্ছে, ওটা করিয়ে দিচ্ছে। बोलची वेबएक्स का लिंक अभी एक्टिव है? मतलब हम लोग को दिखाई दे रहा है टाइम? ठीक है, आपको दिखाई दे रहा है ना? ठीक है ठीक है ठीक है ठीक है,
করে দাও ডেটটা, ঠিক আছে?
हाँ
তারপর বাইসেক, তারপর
So we'll be starting with our next session today. So there will be a presentation by the Gram Panchayat and VWSC members from Dahod in Gujarat. So I'll kindly invite Mr. Amir Vajpayee and Dharmesh Trivedi from Sini Tata Trust and Mr. Chhatra Singh Solanki to kindly take out and share their experiences about IoT implementation. So JJM is supposed envisaged to be a decentralized scheme, and all the assets and IoTs and all the assets are expected to be maintained, by the ground level people, and it is for their benefits only. Like the program is being implemented. So I'll kindly request Mr. Chhatra Singh Solanki if he can share his experiences and also the benefits he is getting from the IoT project. Speak in Gujarati also. Huh?
Yeah, good afternoon. I would like to share. I will share you a brief background to how we piloted this project in our area. I will give you first background that why as a Tata Trust we are focusing on IoT. Second thing, what are our experiences, and also the voices from the field. Chhatri Singh Bhai, he will share his own experiences. My name is Amit Vajpayee. I'm anchoring drinking water and sanitation program in Gujarat from Tata Trust. My colleague Dharmesh Bhai, he is uh, uh, anchoring overall the technical aspects of the drinking water schemes. And Chhatri Singh Bhai, he is operator and also VWSC members of Bauka village is there in the Dahod. He is anchoring overall, managing overall scheme there in Bauka village. The first point is that why Tata Trust is focusing on IoT. Before going to that, I will share that when we are implementing these drinking water schemes, we are focusing on 3 points. One is that building up capacity of Pani Samiti members, like they should plan their scheme they should implement it and manage it. From that perspective, we are building up their capacity. Second point is that we are also focusing on behavioral change communication, right, from individual level, also at household level, and also the social behavioral change communication. That is mainly to that community should have their own ownership when they are implementing things there at ground level. That is what the key messages will be given at each phase, planning phase, implementation phase, and O&M phase. What are the key messages that needs to be given? The focus is on that way. And third is that the developing power of information through IoT, and that power of information will enable community to build up resilience so that they can also get to know what exactly the efficiency of their scheme which they are implementing at field level. Through under this partnership, we have covered first 2 points. Now we are more focusing on this third point, that piloting this IoT kind of thing there in village level. Now the experience, when we are talking about the experiences, honestly talking, it's a somewhat mixed experiences that we have got from different pilot, and we have tried to focus on different geographies. That it so includes remote interior parts also, like Uttarakhand is there, Rajasthan there, Gujarat, so the tribal parts of Gujarat there, then Leh is also there. So different geographies that we are working. So we try to ensure that technology what we are piloting, that should be the robust. And it's not that we fail any issues. We also fail some operational issues related, like when getting connectivity related issues, that may be system malfunctioning related issues. But thing is that we continue engage with the community so that we can get data on regular basis. Yes, it's just 2 minutes. Sir. Yes, sir. That we should get data on regular basis. Once we started getting data on the regular basis, we can decide on what kind of support that we can provide to the community. Like for example, we install one sensor, chlorine sensor, and if if we are not getting data, so there is either communities not giving, not continuously doing chlorination kind of thing, or there may be a problem in sensor. What exactly the issue, so that we can go to that and we can give training to the community for that point. So these are all different projects that we have piloted. In Bauka village, we have installed this bulk water meter. I think I will invite Chhatra Singh Bhai. He should talk about that. He should give brief information about that. Chhatra Singh Bhai, તમે share કરશો તમારા માટે.
મારું નામ સત્રસિંહ સોલંકી. મારું નામ સત્રસિંહ સોલંકી. મારે 2016માં યોજનાનું કામ પૂરું થયું. પછી લાઇટ નહોતું એટલે 2018માં સોલાર નાખી. સોલારથી અમારી યોજના શરૂ થઈ. પછી સંસ્થાવાળાએ ફ્લો મીટર નાખ્યું. એમાં ફ્લો મીટરથી અમે પાણી કેટલું દરરોજ વપરાય છે એ ડેટા અમને સંસ્થાવાળા મિટિંગમાં બતાવે. દરરોજનું પાણી કેટલું વપરાય. પછી એકવાર ફ્લો મીટરમાં કચરો આવી ગયો, બંધ થઈ ગયેલું. એમાં સ્ટીલની જાળી નાખી.
छत्र सिंह भाई हैं, उन्होंने ये कहा है कि उनके गांव में जो है, ओके सर, सॉरी, छत्र सिंह भाई, what he is saying that their scheme, it was got commissioned around 2016 or 17. There was a problem related to electricity. Then to address that problem, they have installed solar pump in their village. And after completion of successful operation maintenance, after 1 year, this bulk water meter was installed. It was giving to one data that how much water is getting distributed, and another we have also made some setting that it will also get reflected at how much LPCT of water was distributed. That information that we are getting, one is the bulk water, how much water, quantity of water, then also at household level, how what exactly the consumption of at household level. These two data which we are getting from the dashboard. And he also mentioned that he faced one problem during meter, that it has got it has stopped functioning because of the strainer related issue was there. Strainer was not installed. Then they have just removed all that debris that has got, jo bhi choke off that has got removed, and they installed strainer, and again water meter is functioning regularly. Yeah, please.
ફ્લો મીટર બગડી ગયું હતું, કચરો આવી ગયો હતો, એમાં બંધ થઈ ગયું હતું. પછી સ્ટીલની જાળી અંદર નાખી શરૂ થયું. પછી અમારે અત્યાર સુધી પાણી 5 વર્ષ સુધી ચાલે છે હજી.
ફ્લો મીટર ક્યારે નાખ્યું હતું
3 વર્ષ પહેલા
અને હજુ ચાલુ છે?
ચાલુ છે.
The flow meter installed 3 years back and is still up and running.
અને એમાં શું પ્રોબ્લેમ આવી હતી?
એમાં પાણીમાંથી કચરો આવી ગયો હતો એટલે બંધ થઈ ગયું હતું. એ ખોલીને પછી રિપેર કરી ફરી આગળ જાળી નાખી દીધી સ્ટીલની.
That strainer problem was there. A strainer was not installed in earlier, so there was some pipe got blockage, and that has been removed and strainer installed. Now it's functioning very well.
એ નાખવાથી તમને શું થયું? એટલે તમને શું ખબર પડે અને તમારી શું ફાયદો થયો?
એનાથી અમારે પાણી કેટલું ઘરોમાં આપવું કેટલું એનો ફાયદો.
તો એટલે હવે લોકોના ફોન ઓછા આવે?
પાણી આવે કે નહીં આવે?
પાણી આવે કે નહીં આવે એના માટે કરે ફોન.
તો એટલે અગર પાણી નહીં આવે તો અમે પહેલા જ ખબર પડી જાય અને લોકો ફોન કરે એના પહેલા જ તમે એના સોલ્યુશન કરી દો તો લોકો પછી તમને હેરાન ઓછા કરે.
Now he is receiving low number of calls from the community. Earlier he was getting calls every now and then. This is what a benefit which he can get.
અને તમે કઈ રીતે જોવો છો?
સંસ્થામાંથી મારી પાસે મોબાઈલ નથી એવો પણ સંસ્થામાંથી લેપટોપ મીટિંગના દાડે એમને બતાવે આટલા મહિના આ મહિનામાં આટલું પાણી વપરાયું.
We used to have monthly meeting with the Pani Samiti. During that monthly meeting, this data used to get displayed to the Pani Samiti members. How much consumption of water for that month and how much water distributed per household level that way. Thank you.
Next, we have a presentation on new developments in geospatial technologies and how they may be integrated with IoT sensors for smart water management. So for that, we have a team who will be joining us online from Bhaskacharya National Institute for Space Applications and Geoinformatics.
Namaskar, sir. Am I audible?
Yeah, you are audible.
Sir, very good afternoon to all of you. This is Manoj Pandya from again. On behalf of Dr. Ajay Patel, I am conducting this presentation. With me, Mr. Sumit Prajapati is there, Project Manager IT, GIS, and Tupti Parmar is also there. She is Project Manager IT. So first of all, I would like to give a brief presentation on BISEC. And then I will just demonstrate about geospatial portal we have developed for Jal Jeevan Mission. So should I continue?
Yes, please continue.
Okay. So,
Hello.
yes.
Just wait for 1 minute. There's a technical snag here.
Okay.
The team from BISEC, can you share your screen?
Yes. Yes. Maximize here.
Sir, you can continue your presentation.
Yes, yes. Is this slide visible to you?
It is visible and you are audible also.
Okay. So first of all, good afternoon to all of you. So this is Bhaskaracharya Institute for Space Applications and Geomatics building. BISEC is located in Gujarat, Gandhinagar district near Info City. So about BISEC, let me give a very brief introduction. It is a society under the Ministry of Electronics and Information Technology. The governing council chairperson is Honorable Minister Mighty, and it is having so many standards: ISO 2015, CMMI level 5 for development. Technology developed is in-house and using R&D. No commercial or proprietary software used so far. And all the projects are executed under the collaboration or partnership of the department. And financial mechanism is self-sustainable. BISEC is earning only from the projects delivered the concerned officers or department. BISEC is having so many technical infrastructure like teleport, studio, telecast facility, high processing computing systems, and so many labs are there. More than 600 plus employees are there. So many students visit regularly. They are given from program statements and they conduct a very state-of-the-art research work. And the scope of the BISEC is to develop technology and institutionalize applications and make it understandable, usable, and simple to use. And ultimate purpose is to serve to the society and the government. So what are the benefits? Benefits to the society is socio-economic sector, proper decision, saving time, effort, and money. So BISEC is having some geo database, and foundation is multi-purpose, multi-temporal data sets, large-scale geospatial data set. Within this database, we are catering multiple departments. So these are the 4 pillars of the BISEC. One is acceptability. Why acceptability is there? Because it is very simple to use, and affordable means it is very low cost. Adaptability means it is made in open source, modular, pluggable, and available means it is cloud-based architecture, available to end user 24/7. This is just a brief collaboration how BISEC is conducting a framework. So ultimately, we get vision, guidance from Mighty, and funding is done for infrastructure and R&D sector. BISEC, with the help of the concerned department, get the problem statement, domain inputs come from the department, data is also validated from them, and funding is given from the respective officers department. So BISEC is having, what BISEC is doing, designing proof of concept, capacity building, development of the complex solutions, and sectoral integration of the problem statements on the cloud environment. This is just brief introduction. I will not go in detail because we are running short of time. But these are the some of those technologies and which BISEC is working. Geospatial technology, ERP, AI, ML, cybersecurity. These are all the R&D areas which are operational and converted into application. Some of the areas marked in the red line are augmented reality, virtual reality, fluid dynamics, flight dynamics. These are the area, these are under the R&D stage. So technology used in governance, disaster management, planning, so many sectors are there. G2G, government to business, G2C, these are the areas where BISEC is already catering the services. So how many ministries are affiliated with BISEC? BISEC has catered and served so many solutions to defense, housing, urban affairs, mines, railways, textiles. So there are so many, roughly 1929 ministries are there where BISEC is providing solution with the respective collaboration. Thank you very much. And now I would like to demonstrate about the portal we have developed and envisage for Jal Jeevan Mission. Is it visible? Sir, this is a Jal Jeevan Mission, Har Ghar Jal. This is
It's not
an-
visible as yet. Just
Oh.
give us a few seconds.
Pardon? Is there any issue? Should I continue?
Just wait for a few seconds. We'll just, the screen is loading.
Okay.
Could you reshare your screen, please?
Okay. Now it's
Yeah.
visible?
Yes.
Yes. So as far as the geospatial solution is concerned, BIOSEC has developed one portal for Jal Jeevan Mission, Har Ghar Jal. This is the main landing page of the portal. After clicking on login page, we will be having so many features in the portal. We will see in the next slide. So these are some of the components which will cover through the course of this presentation. One is basic features in the portal, dynamic dashboard, navigation, dynamic query module, API linking, reporting, planning for new infrastructure with the help of vertical profile or terrain profile. We have mobile application, asset mapping through mobile application. On the go, we can have vertical assets in the form of polygons or line or point. We can mark using mobile application. And last, we will say capacity building. We can provide studio. We can have virtual meetings and other LMS tools are also available. We will discuss in the course of this presentation later. So I will now request our colleague Srimati Trupti Parmarji. She will deliver the presentation regarding the basic features available in the portal. What are the tools and features available in the portal? So I will hand over this presentation to Trupti Parmar. Please continue.
Good morning to all. In a geospatial page, we have in left side of the page, we have the tools. In the right panel, we have the layers group. In the top right corner, we have the dashboard and the report. In the tools panel, we have the navigation tool. We have the query builder tool. We have the proximity tool, line of sight tools, and terrain profile tool. In the right panel, we have the pan-India layers. In pan-India layers, we have the transportation network, water resource, habitation, health facility group, national corridor group, smart city group, aspirational district group, and census data group. In pan-India layers, we have the transportation network. In transportation network, we have the rail connectivity. In rail connectivity, we have the railway lines, station. We have in transportation network, we also have the road network. In road network, we have the national highway, state highway, major district road, other district road, toll plaza. In water resource, we have the stream layers, watershed layers, existing check dam layers. You can also get the information by clicking on the particular layer. Now you see that on clicking on the stream, we get the information about the drainage information. In drainage information, we have the name and the node information. In watershed, we have the watershed name, a basin code, that catch code, water code, and the region name of the particular watershed layer information. In a water resource, we have the existing check dam. In check dam, we have the taluka name, state name, village name, and the particular check dam name. In habitation, we have the settlement and the settlement extent information, layer information. In health facility, we have the CHC, district hospital, government medical hospital. By clicking on the particular layer, you can also get the information of the about the layer. In national corridor, we have the national corridor layer. We have the smart city layer, which display on the map. We have also the aspirational district layer on the map. You also see that census data on the map. In census data, we have the information about the number of household, total population, male, female population, ST population, ST male, ST female population. All the information are you can view by clicking on the particular census data. It is on census 2011 data, sir. On dashboard, we have the we have the one asset mapping group. By you can add the layer about the water network and the water bodies. Whatever the you are marked on the water asset mapping, this is the dashboard of the asset mapping. In asset mapping, we have the water network, the water bodies on dashboard. You can get the number of count of the water network mapped on the map layer and the number of the length of that water network. Also, you after clicking on the more information, you can get the report of the whatever you can mapped on the asset mapping of the water network. We also on the view on map. You after clicking on the view on map, you can navigate to the particular layer on the maps. We have the query builder module. You can select in query builder module. We have to first select the layer water network. Then you just have criteria based query on the map. After clicking on the submit button, you can also get the query criteria based map layer on the map, sir. Now this is the panel of the asset mapping. First, you have to navigate through the navigation tool. I am here. You are able to see the navigation tool. I am selecting the state Madhya Pradesh. Then I am selecting the district Sagar. Then Taluka Sagar and village is Agra. And then I am selecting this add water data. After clicking on the water network, you just have to mark on this particular network. Then I am marking of that in that layer. After marking, you can see.
Oh, yes, sir. So actually, yes, Tupti is trying to convey that there is one tool. This is called as line of sight. One button is given. Once you click there, a small pop-up opens. In the first button, it is marked as mark a line on map. It means person has to click on the map and start marking segment. After marking the segment, there is another button, say visibility profile. So we can have interaction with the vertical profile we get after clicking on this button. So this is a thing which we see wants to convey. In the right hand side, I have a profile. In the x-axis, I have the distance, and y-axis, I have altitude. And in this map, I can also have interactive chart. So the blue color stars shows the interactive instantaneous value of the pixel. So on the go, I can see and get the respective pixel value of altitude. So this is what she wants to convey, that we can have entire India, pan-India DM available. So by just clicking on 2 points, we can get the terrain profile. This is the thing so far. Any question? Should I continue? Okay. Now I would like to focus on geospatial technology and IoT. I think before my presentation, some other fellow members have nicely presented about the present case study solutions, including challenges and IoT development and so many things they have discussed. So thank you very much for that. But as far as geospatial portal is concerned, I will just focus only this diagram. This is a very holistic view mechanism. So we have IoT in the center. It has sensors, network, and it is connected with internet 24/7.
Can I interrupt you a while?
Please.
So actually, the previous part where at the village level, the water supply network or households can be mapped. I think that part, if you can explain a little bit more, that will be more useful, because IoT part we have had a discussion for last 2 days, and we understand that we will use that a little bit. Maybe you can have few slides at the end. But suppose I have a network diagram, can I import it and superimpose in this portal and correct it and things like that? If those, kindly tell us about the functionality, how I can map a village distribution network or a distribution network of a block or a group of villages. Those possibilities are there or not?
Oh, yes, it's a good question. As far as your question is concerned, what I would like to say that we have shown very holistic view, broader level, but you are talking about village level. So definitely you can make your sketch or diagram as per your requirement, and then we can have this profile. As for example, I have shown a very straight line and very broader, I think it is about 56 kilometers of span. But you can zoom in the map up to village level. You can mark segment by segment in the say meter, 2 meters, or several meters, just 50 meters, 100 meter like. And then you can get the same terrain profile. So you can find the elevation in the y-axis. Is it okay? And yes, second thing is as far as your sketch or diagram is concerned, so far there is no mechanism to import your diagram because we don't know in which format your diagram is. So generally in geospatial technology, we consider, I think, KML file or GeoJSON file or the ZIP file. These are the most commonly used formats in geospatial technology. In other case, you can also discuss with us which kind of format you are sharing or you want to sharing, and accordingly we can develop the tool. Is this okay?
So KML files and AutoCAD files, that shape files, I think those may be available with the engineers at field level, because normally contractors are implementing our projects, so they will have some kind of diagram available with them.
Yes.
So AutoCAD files, can that be imported?
Yes, AutoCAD file is there, but sometimes the projection related issue also occurs in the AutoCAD drawing. But most alternative format is available is KML. Most of the surveyor teams also are familiar about Google Earth and Google Maps. They also use or they are acquainted with KML. So KML is very interoperable open format.
KML will not be available with water supply engineers because they make their diagrams in AutoCAD mostly. So can there be some kind of transformation, and then can that be converted to KML if it is necessary, or can it be imported? Is it not a possibility? And then geo correction referencing, those things can happen on your portal. Is it possible or not possible?
No, that's why I'm saying, because if your data is not geo-reference, it is not possible to superimpose on the map. So first of all, it has to be geo-reference somehow. Because we are dealing with some system. We have a projection system, whether it is a geographical system, whether it is UTM or any other projection system. It has to project it in some frame of reference. So we are using WGS84 datum, and GCS is the projection system. This is the frame of reference we are using. So once it is the same frame of reference, we can superimpose. That is what I want to convey.
Okay, you can go ahead and finish the presentation.
Okay. So I will now focus about geospatial technology and IoT. This is just we have envisaged at our level. So IoT is there. There are many sensors, there are networks, it is equipped with the internet, and of course IoT periodically sends that information to cloud, and cloud is there, and National Jal Jeevan Mission has also done some pilot level projects. They have some protocols, some dashboard, communication guidelines are there. And how geospatial technology can be useful. Geospatial technology or this data can be used using some APIs. All this location or the network stations have some location value. So latitude, longitude value will be considered as an entity for geospatial data set. Using this API, this information will be fetched on the portal. Then it will be geo-processed, filtering, analysis, visualization, such kind of things can be possible
Hello, sir. Sorry to interrupt. Due to paucity of time, we have to complete the session by 5 minutes, within 5 minutes.
I'm sorry. Okay, I did not have idea. I'm running out of short of time. So this is just a holistic view. And last but not least is mobile application. Bisec has also developed one mobile application to capture various features, various network. And one more thing is offline also. So if you do not have 2G, 4G network, it will also capture the data in the offline mode. And once you come in the vicinity of the network, then it will sync with the data set, and this database set will also get reflected on the live portal. This is what I want to convey through this diagram. And this is just a schematic view. For example, suppose I have received data through API, and my geospatial data set will translate into field and columns. So in the left hand side, I have fields like source ID, source, turbidity value, TS, fluoride value. And the right hand side, its respective value will be populated automatically. And in between, I have some operators, Boolean and logical operators are there. After applying these logical Boolean operators, I will get reflected on the data. As for example, here I have just passed one statement, TDS greater than 200. And once after clicking on apply, it will get reflected on the map. We can also create complex query using permutation combination of logical and Boolean operators. So, and last but not least is one mobile application is there. I think this is just we have this snapshot of the mobile application. So this is just login screen. After a login, I will get some menus. As for example, there is a scheme, pipeline, head network, water network. These are the some of menus available. The user can select either of them, and after going into the field, the user can mark on the go. As for example, these are the push pins. Suppose I am interested to mark one point here, second point, third. All the push pins will be marked, and a closed polygon will be automatically generated, and this picture will be reflected on the map. And a corresponding attribute can also be filled online as well as offline. As for example, scheme name, population, cost, scheme status, number of headworks, etc. Similarly, we can do the same thing for pipeline on the go, and there are parameters, head work, the parameters, all these assets can automatically be mapped using this mobile application. And last but not least, we have learning management system available. So one can also find how to operate. As for example, I do not know how to use mobile application, how to use the terrain profile. So we have developed small videos, buffer tools, navigation tools. These tools will be available online. One can download and view on their mobile as well as in system. This is the thing so far. Thank you very much. Any questions you can ask.
So thank you very much. I think that was helpful.
Yes. Thank you once again.
Thanks a lot, sir. So we'll move on to the last session of the workshop. For that, I'll invite Mr. Sunil Kumar Panchal from Piramal Foundation to kindly share their on-field experiences of IoT implementation. I'll share the link in the WhatsApp group, sir. We'll prepare a Google Drive link and share in the WhatsApp link. Right. Session by session, all the presentations will be there. Hello.
Excuse. First of all, good afternoon, everyone. I'm Sunil Kumar Panchal from Piramal Foundation. I thank you, everyone, for giving us this opportunity to share our learnings in IoT. Most of you may be aware about Piramal Foundation, but for the sake of others, I would like to give brief introduction about Piramal Foundation. Piramal Foundation has been transforming lives in health, education, water, and social sector ecosystems through partnerships, high impact solutions, and thought leadership. Our presence is in 27 states and 2 union territories. And in the past 15 years of the foundation has touched the lives of more than 100 million Indians by focusing on the most marginalized groups, implementing impactful initiatives and engaging youth in nation building efforts. So I'll give you a brief introduction about what we have done in IoT. One of the initiatives of Piramal Foundation, who has been working in the water ecosystem since 2010, by providing clean, safe drinking water to most underserved people by bringing water purification plants, and where safe drinking water is dire need and there is a high contamination in source water. So our expectations, our operations are scattered and distributed, whereas our data management is centralized. In the water ecosystem, we understood what are the challenges in last mile delivery. So the major challenge is what we face, like how to monitor the functional status of the machines, which is operating remotely, how to monitor the quantity and quality of the water that is being produced and delivered, and what are the how we can monitor the activities of IC, right? So we understood that technology will play a bigger role here because machines are scattered, they are running at the various locations, but we want to data at central location. So we use IoT technology and cloud to collect the data from all the machines. By this way, we were able to monitor the water production from each water purification machines. We were also able to continuously monitor vital process parameters and user level transactions. We have done this innovation in India, but we got its patent in US. So if you look at how what kind of data we are getting from our machines, so basically we are getting two types of data: transaction level data and machine level data. In transaction, each consumer wise data we are getting, like how much water they are consuming, and based on that water consumption pattern, we are able to provide them targeted subsidiaries. In machine level data, we are getting vital process parameters. We are also getting sensor information and sensor errors, if any. Based on that, we are able to plan proactive maintenance. And it also helps in volume taking and making IEC activities. The data coming from different locations, we aggregate, and that helps us in measuring district and state level data. And then in real time way, we are able to monitor daily, weekly, monthly, and annual production, right? So the data that comes to our central data management systems, where machine vital parameters are coming, and we are also getting consumer level data. So that helps in preemptive maintenance and planning for IEC activities. And we are also able to estimate operators incentives, and we are able to monitor quality of the water that are being produced. So during COVID lock time, our machines were operating 94% on time. In the year 2018, we signed a MOU with Niti Aayog for Swajal program, which was a precursor to Jal Jeevan Mission, for validating the design principles. Under this agreement, we were assigned 16 aspirational districts in 7 states for creating awareness of the scheme among community. We also built community ownership, and we also helped forming VWSC and DPRs and Gram Panchayat resolutions. And we were also helpful in funds mobilization. So in most of the criteria, we were above 100%. And we also got acknowledged from Niti Aayog for our achievement. During Swajal program, Piramal Foundations spent some time and designed IoT-based remote monitoring for water supply scheme. So according to our existing Jal Jeevan mission, this comes under basic scheme, whereby we install sensors for groundwater level monitoring, measuring water quality and water quantity, tank water level, etc. And we developed a dashboard for scheme level, district level, and at state level. We demonstrated our innovations in Assam, Bihar, and Gujarat state. And our learnings of 10 to 12 years in IoT, we took these learnings in other domains as well. So in Bihar, we were working under state transformation program, where we demonstrated use of IoT technology to monitor medical device utilization. So under this project, we were monitoring X-ray, radiant warmer, dialysis machine, and different kinds of medical device. Using IoT device, we were able to monitor what is the uptime, how much their utilization, all these parameters we monitor, and we demonstrated this to government of Bihar, and they like this, and now they are scaling it up across Bihar. So these are some of the dashboard where we can monitor what is the live status of the all medical devices, whether they are getting electric supply or not. So all these things we are demonstrating, and we could also monitor historical performance of the medical device, what was the utilization in last 6 months, that also we can monitor. So as you know, Department of Drinking Water and Sanitation has formed Rural Wash Partners Forum. So under that, there are 12 thematic areas, and Piramal Foundation is leading one of the thematic area, that is innovation and R&D, including use of technologies. So as we know that in Jal Jeevan Mission, functional tap connection is very much a critical criteria. And to achieve that criteria, we believe that IoT is the main backbone, right? And since Piramal Foundation has experience in this area for last 15 years, so we could say that our whatever work we have done in decentralized operations or pipe water monitoring and medical device utilization, that will be definitely helpful to all our stakeholders, our partners, and we are ready to help them. We even at the scale up level, we have installed our purification plants at 2,000 plus locations, and right now we are in RWPF. We have partnered with 3 states: Jammu Kashmir, Jharkhand, and Maharashtra. And we have recently signed MOU with PhD Department Madhya Pradesh for establishing tech support unit. And we are happy to help all our state partners in providing whatever way we can do. We can also work as a consultant for them. Thank you very much.
So friend, this Rural Wash Partnership Forum is one such forum where you can get that tech supports our Puducherry friends was asking. Each partners have been mapped, various partners have been mapped to various states. And I think that list is already shared with you. It must be there with the state headquarters. Get in touch with them. Ask them, people like Piramal Foundations and others, to come to you, and they will provide you basic 2 or 3 people who will help you to navigate through this IoT thing.
So with this, we'll be closing session, and I hope like this 2-day workshop has been like useful for all of you, and like you will be now equipped, for planning, designing, and preparing BOQ for IoT solutions. And I'll just share Pradeep sir, if he can just share some closing address.
So we have few minutes. So rather than me sharing, I would request those states who have not spoken so far to come here and tell them how they felt and how was the experience, and maybe a few things they can highlight which we can help so that the next workshop we can improve a little bit. So I will voluntarily ask first, and if you don't come, then I will have to see the list. Please. So 2, one from this side and one from this side. Anyone? Please come.
Very good afternoon to all of you. Myself Vikas Balen, and I am working as an executive engineer in Haryana. So I have with my superintendent engineer is also here. Actually, sir, we are working in field from. I am working in field from last 13 years. Lot of experience and lot of problems from field I have to experience. But here, actually, this session helped me a lot regarding IoT and other devices. I have no knowledge about that, but in yesterday's session, it was very helpful and I have learned a lot from it. Hopefully, I will uh, the, I will get it. Hanji, जी sir. कि फील्ड आई विल फील्ड में इसको इम्प्लीमेंट करने में आई विल श्योर टू इट. थैंक यू.
Good afternoon, everyone. Honorable Director Sir, dignitaries sitting in front of me, participants from all across all the states, and my dear friends and colleagues. It has been an amazing experience being here for the last 2 days. We weren't told about these IoT things. I got a call from the chief engineer's office 2 days prior to coming here, and they kind of told me that you have to go attend a session on IoT here in Kolkata. So it was a really surreal feeling for me. I don't know. I was not expecting. I didn't know what I was getting into, but the kind of knowledge that we got over here for the past 2 days, and the kind of experiences, getting to listen to all these dignitaries and all these resource persons, it has been a really amazing experience and enriching one. I am sure sessions like these and um, session like this is going to go a long way in bridging the gap of these of the field engineers and of the expert members. So if these sessions like these can go on and continue, I'm sure it is going to curb the bridge or kind of bridge the knowledge gap between the field level engineers and the um, superior officers, of course. Thanks a lot. It's an amazing experience being here.
Good afternoon, sir, and everyone present here. I'm Sarakani Purto. I'm a subdivisional officer from PhD Meghalaya. So in Meghalaya, the IoT, whatever we are learning from here, regarding the IoT, we are yet to implement and we are yet to start. And through this workshop, it has helped us in many ways, especially in learning regarding the preparation of BOQ as of yesterday, and the GM portals, and also like especially regarding the communication network, where we are a bit Greek on that, regarding how to prepare your schemes based on your like communication, like GSM and other things, and especially in hilly areas. Like Meghalaya also is also one of the hilly areas where we do have issues regarding communication network, and especially today learning like regarding the intake portion where we have less network, and the treatment plants at the higher level where we get a better network. So these are the things we can really plan and do our planning based accordingly. And I hope whatever we learned today, me and my team, we will try to incorporate in Meghalaya, whatever knowledge, the concepts, and whatever you have taught us today. Thank you so much.
Very good afternoon, all of you. It was an hectic session from yesterday. Several interactions have taken place, technical, techno-commercial, and other parts. Everything was discussed. Now it's a time for valedictory. I wish to thank our director, SPM Nivas, who is the key gentleman who powered this entire workshop. We have a deputy advisor from our ministry joined today. We have professor eminent from the IIT Kanpur, other dignitaries in front of me. Our office, SPM Nivas, colleagues are here. I wish to thank them. KRC partners, RWP F partners, Tata Community Initiative team, expert teams. Lastly, not the least, all of you, pan-India basis who have visited here in a short notice, all joined. Hope this day was, may not be excellent, but we try to arrange whatever possible due to, Sankranti connected engagements, all that. So we'll try to improve upon, and we'll look forward to see you once again on a different workshops. So I thank you very much, all of you. I invite you for the lunch at the same location. Thank you very much.
Shautik, yeah, feedback.
So we'll be putting a feedback link in the WhatsApp group. Request everyone to kindly fill that. So it will help us, to plan more fruitfully in the upcoming sessions. And which of the sessions have been like more useful and relevant to you, if you can mention in the feedback form. And if there are any suggestions like the communication network related workshop and something, just put in the suggestions. We'll try to incorporate those in the upcoming sessions. Thanks a lot. And I'll request everyone to collect their certificates from here. I'll call one by one states. One of the member can come and collect the certificates. Right. One member from each state can come and collect. I'll request Professor Sir if he may please kind hand up. We'll request Arunachal to kindly come.
One representative from Arunachal, please. Representative from one, have some more, so please. Next is Bihar. One representative from Bihar, please. Next is Chhattisgarh. One representative from Chhattisgarh, please. Thank you, sir. Next is Gujarat. One representative from Gujarat, please. Next is Haryana. One representative from Haryana, please. Himachal Pradesh. One representative from Himachal Pradesh, please. Himachal. Next is MP. Only one certificate. One participant from MP, please. Sir. Next is Meghalaya. One representative from Meghalaya, please. Mizoram. Next to Meghalaya is Mizoram. Representative from Mizoram, please. Punjab. Next to Mizoram is Punjab. Sikkim.
Sir, I guess Punjab has maximum participation.
Maximum participation from Punjab. So,
Loud participation.
thank you very much, sir. Next is Sikkim. Tripura.
West Bengal, one representative from West Bengal, please. Puducherry, one representative from Puducherry, please. One participant from Jharkhand, please. And similar, Manipur also. Jharkhand, please. Participant from Jharkhand. Jharkhand, sir? No, Manipur. Mr. Saket Kumar from Jharkhand. I don't think he is there. No. Thank you. ये तो अब सर से पूछ लेते हैं. Thank you. So thank you very much to all. Thank you. This is all about certificates. Next to Satik, please.
I would again request everyone to kindly fill the feedback form and put in your suggestions. And sir, shall we break out for lunch? So we can just we will break out for lunch. Just request anyone who has been contacted for the media buys, kindly stay back for 5 minutes. Others can move on for the lunch. So it will be in the same place as was yesterday.
Thank you so much.
Yeah. कौन सर मैम को बोला था मैम प्लीज ठीक है एनीवन फ्रॉम छत्तीसगढ़ सर yeah say something presentation अरे सुभाष मीडिया में
Section. All of the sections are extremely for the actually some of the experts like Dr. Babban Kumar, like very lively presentation and very informative presentation. With the guidance of the Steve, was really a very nice. The actual work actually starts now for the participants who have learned a lot, interacted a lot. I wish all of them the best. Yes, yes.